Hey, everyone. How are you doing? It's Daniel here, developer advocate at Strapi, and I'm your MC for the day. Welcome to the integrate stage. If you look at the StrapiConf stages, we have special themes for each one. The integrate stage looks at third-party solutions and tools and how they integrate with Strapi. I'm very excited to welcome you all to the integrate stage at Strapi's first ever user conference. And just to do some housekeeping, I would love it if you could all share a picture of yourselves wherever you are and how you're watching the conference on Twitter using the hashtag StrapiConf. And who knows, at the end of the day, there might be a prize. All right, so let's get into our first talk. Our first talk is from Charlotte, a software engineer at MeiliSearch, who will be talking to us about integrating open source search into your Strapi project. Remember, if you have questions for Charlotte, please ask them in the questions channel under the integrate category. Charlotte, take it away.
Hello. I want to say thank you to Daniel for supervising my talk. I am Charlotte. I am a software engineer at MeiliSearch, a open source search engine. So today I'm going to talk about how to add a search engine to search through the data you have on Strapi. So just to give you a bit of a insight, I began going on the web in 2003 after stopping playing SimCity 2000 to save my people. So with my innocent eyes, I have seen web evolved, and with every decade, a big problem has been solved. So around the years 2000, you had really ugly and slow websites, even if, the slow part was mostly due to our connections problem. But then arrived CSS and the popularization of CSS, which made website more visually attractive. After that, in around 2010, I saw what we call the reload fiesta. So websites became more complex. You could do more things on it, but every action needed a reload, and on each reload, you had to download the whole web page again. So today with the fiber, it's fast, but at that time it took some time, and it really reduced your available data. But then, for example, PHP BB2, for those who remember those kind of forums, it's typically something where you have to over and over reload. But then came Ajax, so asynchronous JavaScript, which made sending HTTP requests from your client in an asynchronous way. So you could send a request and not wait for the answer. And when it came back, you could fetch the answer and, for example, show a notification saying your post has been added correctly. And finally, today we have the pretty fast and powerful websites where everything is possible. So many libraries have been added, features to make a browser even more powerful as service workers, and CSS frameworks to make creating a design so easily. So you might think, well, there is no problem left then. I wouldn't be here if I agree with that. And if you saw, of course, the title of the talk, you might have guessed. Today, the problem remaining is in-app search is still bad. It's commonly bad. You have exceptions, but on most websites, you are still not really happy with what you have. So initiatives have been taken, such as a Google custom search, but it wasn't a great experience, as almost any search brought you to another website. Today, most of your experience are still frustrating. So here I showed an exaggerated example where you will go on a website, you will type something, wait a bit too long, and then the results are underwhelming. You will maybe try again with another word, and again, it is underwhelming. This is frustrating both for the user, but also for the developer that try to implement something acceptable. So the user has lost its trust in your search engine and is faced with two possible solutions. The first one being what I call the drop-down hell. In that solution, you decide to go through the navbar to find the content you are looking for. So maybe you go in the first category, that brings you to the second one, and so on. And every time you have to be careful not to bring your mouse outside of it, because if you do that, the whole thing just closes and you have to start all over again. So at the end, you may find what you're looking for, but the experience is not pleasant. The other option that you may take is going to the fallback options. Fallback options are websites where you can trust the search, for example, Amazon, AliExpress, but it's not the ideal solution as you are limited to what they offer. And also, they have a trustable search because they mostly have a whole department of developers just working on the sole purpose of making their search, making a quality search experience. What is the problem? Why do most websites not have a great experience? Well, when a developer chooses a search engine, he thinks about three criteria. Or there are others like being fast, but that's mostly the case today with any option. The first one being simple to implement. Is it simple to implement? Does it have a lot of configuration to do? Does it take time? Do you have to hire developers just for that one task? The other one is open source. Maybe you have an open source philosophy. Maybe you want the security to put your data on your servers. And then you have a relevant. When you make a query, are you satisfied by the returned results? So this is a compromise triangle. You can only choose two. You can never take the three. So if we go for couple to couple, the first one being simple to implement and open source. You typically have the SQL queries. Okay, so the open source databases, SQL databases, you will probably already use it because you store data and you wouldn't search without data. So to create a search experience, you will just do another query to your database using, for example, the like operator, but it's limited in relevancy and it is really strict at just giving you back the exact matches. Then you have open source and relevant with, for example, Elasticsearch, which is a great tool for a lot of use cases, but which lacks in a pre-made configuration for known use cases. For example, looking into products, looking into a blog, whatever use case you have, you will have to configure it. And the configuration might be hard, but also the search requests, as you have to create whole objects specifying exactly how you want Elasticsearch to handle your query. Also, of course, the learning curve of Elasticsearch is quite hard as you have to really read the documentation before you begin. Lastly, we have the relevant and the simple implementation. Those options are mostly SaaS options. So you will have companies that uses Elasticsearch and that created a configuration that suits the common needs. And then, well, you have to use their service to be able to have that experience. And for example, another one is Algolia that is relevant and also really simple to use. They have a design that also inspired us in our API design. So you might think, well, okay, well, I want to not have to compromise. What is the solution? And without surprise, the solution is, of course, MeiliSearch. As we are simple to implement, it's our biggest focus. We are open source. It's really important that we follow open source philosophy, and we are relevant out of the box. So without any configuration during setup, but also during search, you will have relevant results on your data. MeiliSearch. We started 2 years ago, creating the search engine in Rust to ensure the most optimized and fast way to look through small and bigger datasets. And today we are at 13,000 stars on GitHub. Do not hesitate to add yours, of course. And we are still growing. I will now show you a demonstration on a use case of MeiliSearch. This is MeiliSearch MoMA. So Carolina, that worked with us, retrieved the whole dataset of all art that was ever exposed in MoMA inside MeiliSearch, so that we are now able to search in it with our search engine. Let's try to go full on typos. So we're gonna write persistence, and with those typos we still find what I was looking for, the Salvador Dali persistence of memory. We can try another example. We can try more fault, and here we have words that are in a bad order, typos, but still what I was looking for, being René Magritte as a proud Belgian. All right, but we could also just use the facets that we have to our left. So let's find a painter from Mexico, a female. And here we have Frida Kahlo. And also, as you could observe, there are approximately 50,000 art pieces on that demonstration, and it doesn't stop MeiliSearch from being, way more, 138,000 art pieces. And for example, we can have another one, Starry Nights, and then we have Van Gogh's Starry Night. Well, that's for the demo. So you can also order things and search for maybe anything you want. So now that you saw an example on how to use searching with MeiliSearch through a big data set, you might ask yourself, okay, how does it mix with Strapi? So to begin with Strapi, we share the common value of open source and its philosophy, but we also share our love for accessibility and simplicity, as we want both our products to be as simple to use as possible, and thus being available to developers of all levels. Now, Strapi being a CMS, a backend CMS, you mostly gonna have data stored through your Strapi application, and MeiliSearch needs data to search through. So it's a match made in heaven, as you probably want to search through your data that is on Strapi. So I'm proud to present the Strapi plugin MeiliSearch, where simplicity meets. Our objective with that plugin is to create best of both worlds, creating a plugin that is as simple to use as Strapi and as simple to implement as MeiliSearch, but the communication of both of them. For the demonstration, we are going to see how we can add MeiliSearch to our Strapi application, and after that, how we can search on the data. So we will start in a Strapi application, installing the plugin. So in our case, it is Strapi plugin MeiliSearch. And now we have to trust NPM to be fast enough, which is not always. Yes, all right. Okay, now that we have installed MeiliSearch, we can launch our Strapi application. Well, our Strapi API. Okay, so here it is. Let's go on it. To the left side, we can see that I have created a collection type that is restaurant. I have based that on the quick start of Strapi. So it's basically the same. I have added 2 restaurants, the Butter Biscuit and the Butter Biscuit and the Slimy Snail. And now let's go in our MeiliSearch tab. All right, so we are going to we have a restaurant that is added here because it fetches every collection available. So users is not considered a table on which you can search. Well, for the moment at least. And if we click on it, we first have please provide a valid host. So we first have to start a MeiliSearch server in order for us to have a valid host. So let's go on the MeiliSearch documentation. And if we go to installation here, we have a few options on how to install MeiliSearch and run it. So we are going to use curl. That is a terminal tool that lets you do HTTP calls. All right. So I hope you will find your happiness amongst the other solutions. I created an empty directory called Meili, and I'm just going to copy paste the command that you see on your right. This command is going to download the MeiliSearch binary that is now available here. And to launch it, we just have to / and run it. So if you are on Windows, you might want to use the Docker installation. Our MeiliSearch is up and running, and we have access to some information. We have launched MeiliSearch without a password because we are in development mode and for the ease of this demo. But in production mode, you have to add a password. So here, if we look at the information, we can see that the database path is data.ms, which is now present in this directory. And the server it is listening on is 7700. So we're going to take that link and open it in a tab of our browser. And here we have access to MeiliSearch preview that for the moment contains nothing because we just created it and so it's empty. This dashboard is gonna show your indexes. So indexes in MeiliSearch are like the entity that contains documents. You can have multiple ones and search on different indexes. So now, great, we have a running MeiliSearch that contains nothing. We have a running Strapi. How do we connect both? We are now on the MeiliSearch page or plugin in the Strapi. We can try again. And again, it asks for a valid host. So we saw here that the server is listening on that port. This is our host. All right, so let's take it and add it to MeiliSearch host and then click on that button. So MeiliSearch credentials have been correctly updated. And let's try again. Oh, restaurant is created. So what does that mean? It means that now in your MeiliSearch instance, you have an index called restaurant containing the different restaurants that we have created here. And if you want the proof, we just go back to our MeiliSearch preview and restart the page. And here you have it. So we have the restaurant index, which is the only one, and our 2 restaurants. So let's search in it. Let's say we write butter or even butter, but with a typo, and it finds all documents containing a butter. But if we write garlic, we only have, of course, the slimy snail, which contains garlic. All right, you might have observed that a button appeared on our plugin page. That button here, reload servers. And also, there is a field in our table that is called hooks, and that states that a reload is needed. So what does that mean? For the moment, your restaurants are in MeiliSearch, but if you add new restaurants, they will not be automatically added to MeiliSearch. To do so, once you have added a collection to MeiliSearch, restart your Strapi application. This is possible on development mode when auto reload is set, but not in production mode. So that's why I started Strapi in development mode. So let's click on it. It's restarting the server. As you can see on the left side, everything is restarting, and now hooks are active. If we go back to MeiliSearch, we still only have our 2 restaurants, but now let's add a new restaurant. All right, add a new restaurant, and we are gonna call it the smell of a blue. And as a description, we are gonna say it's how you eat it, with a bit of butter and a lot of happiness. Well, excuse me for the for my bad writing skills. Let's imagine it's written correctly. Okay, let's save it. And now it is added to our list of documents here. And if we go back to MeiliSearch and refresh, it has been added to our MeiliSearch instance. And so if we now write down butter, we can see that the 3 documents are valid answers. So this is a simple example with a small data set. So now that we have seen how you add a collections to MeiliSearch, how it reacts to hooks, we can now go one step further. So I have created a Strapi application with way more documents. Here you have it. I have added 30,640 movies on Strapi. So in the MeiliSearch plugin, you can see that it has been added and it is active. We have added a host, which is 7701, to not clash with the other one that we used. The question is that, okay, of course, if we go to the MeiliSearch dashboard, they all are here, but the design is a bit, well, not really well done. So how can we integrate easily the MeiliSearch search bar inside in an already existing application? Well, that is also something we try to make as simple as possible. So starting MeiliSearch on one side, but then of course is the question of, yes, but how do I add it to my web application or just another application you might have that is not per se on the web? So we have created a tool that is Instant MeiliSearch, which is a client that connects to another open source library that is called Instant Search, and that creates UI elements, that generates UI elements on your web page. So to give an example, up, I have created a basic interface, UI, a user interface for the movies that you can see to your left. It's not a dashboard. It is something I have added myself. And we are going to quickly see how simple, well, from my perspective, I hope it's also for you, to implement it. So on the right side, I created a really basic React application. So it has an index, and in that index, it generates an app component. Well, it adds the app component, and I have added some basic CSS, but not a lot. And when we go now, that's everything I have done. The core business of our front end happens in app.js. So let's remove that. Here, it's all the code that was needed to generate what you see on your left side. So we take the Instant MeiliSearch client, and we get some components created by Instant Search. So those components are hits, search box, stats, and highlight. And how do you integrate it? So the body is here. Let's imagine you have something more complex going on your website. You just have to add these components. So the wrapper being the Instant Search with the name of your index, which in our case, if you look to the left, it's called movies. So that's what we wrote here. We provide the search client that we created above with the right host. And then it's all about what you want to showcase. So I'm sorry, I lost the demo. All right, so we have added that components, the stats components, which is that little part, and that shows you how, during your search on each key that you add, how many results were found and in how much time. So if we look for Lord of the Rings, you saw the results evolve. So if we start again but slower, as it may be a bit fast to follow, so I'm gonna put a L, then an O, then an R, then an D, and you can see that results are going reduce, and the time gets reduced as well, the process time. So of the rings, and once we are done, we can see all the documents that MeiliSearch has found, and also on which basis did they consider the document to be relevant or not. So you have here the Lord of the Rings, but after that you also have other ones that have that are less relevant, but still a bit. And how more you descend into the movies, how less relevant they are to your first query, that is Lord of the Rings. So that's for the stats. Then we have added the search box. As we, for example, remove it, we of course lose the search box, which makes it complicated to do any search, right? And finally, we have the hit component that creates the visuals of each hit. So that's the only thing that requires to be manually created, which is the hit component for each movie. Here we have added the poster with left align, and then two others, hit name and hit description, that both are using the highlight component. And that highlight component is what creates of the rings, is what creates the little orange underline that shows you the matches based on your query. So lastly, to explain just a bit more about MeiliSearch relevancy, if, for example, we write down Truman, or so if we write Truman, we can see the following movies. So the first movie is Truman, and the reason why he is first is because he found an exact match, and he found it in the most important attribute, which is the title. And after that, so just about the importance of attribute. When you create a document here, you can see that we have title and then overview and then poster. The order in which you create those fields determine by default the importance of each field. So here, title will be more important than overview. This is, of course, changeable, customizable, configurable, but by default, MeiliSearch suppose that it's the order of importance. So yeah, because it's written at the start of the most important attribute, it is considered the most relevant document. The second document has also Truman being written correctly, but a bit further. That's why it's the second one. When we go to the next one, it's even not present in title, but it's at the start of description. So again, that's why it's more important than the next one that has, well, it has a typo and it is further away. All right. Okay, well, that's the description. That's how you create MeiliSearch, how you add it to Strapi, how you then add your collection by clicking on that checkbox to MeiliSearch, as you can see here, indexed in MeiliSearch. And once everything is done, you can then add the front-end elements to your website quite frictionlessly. Not sure that word exists, but you get my point. All right. So the demonstration being done, there is nothing more to know about using MeiliSearch and Strapi. I have added here the GitHub repository where you can find more about both the plugin and the tool I have used to show the UI elements. But you might think, well, Charlotte, what you showed us was in production, was in localhost, and everything is always nice and easy in localhost. So you might ask yourself, what about production? So, of course, it's something more complex, but even for that, we try to make it simple for users. So we have created some tools to create really easily an instance of MeiliSearch. So, for example, you have the one-click install on DigitalOcean, on Amazon Web Service, or on Docker. I hope you will find your happiness here as well, so that production is as frictionless as possible. All right. Thank you a lot for listening until the end, for those who are still here. I hope you a nice day. And if you have any question, I will be answering them.
Thank you so much, Charlotte. I absolutely loved your talk. Search is so important on the web, and it's pretty cool to see it getting smarter and smarter each year. Let's welcome Francois Nadeau, the CEO of Snipcart, with his talk on the state of modern e-commerce. Let's drop some emojis in the Discord chat for Francois. Francois, take it away.
Thanks for the introduction, Daniel. Hi, everyone. I'm Francois, CEO at Snipcart. Snipcart is a lightweight e-commerce solution for developers that you can add on top of any website, be it a trendy stack or a more traditional one. We've been doing this for almost 8 years now. So needless to say, e-commerce has evolved a lot since then. And I'm very happy to be here and discuss this with you all today. The title of the talk is The State of Modern E-commerce. But what's the goal here? The goal really is to just help you make better decisions when choosing e-commerce solutions. And to do that, you need to better understand the modern e-commerce landscape. So how can we do that? By going through these 4 points. So first point, functionality. More specifically, the fragmentation of e-commerce functionality. We'll cover all of these different functionality blocks that we can find in different modern solutions. Second point, we're going to do a technical paradigm overview. And by paradigm here, it's just a fancy way of saying different approaches that you can have as a developer towards e-commerce. So for instance, what kind of building blocks you choose to use and how you assemble them. The 3 main ones that we'll cover here is monolithic, JAMstack, and Headless Commerce. The third point will be about categories. So there are a lot of new and old e-commerce categories, and it can be a bit messy to try to find your way through what is what does what. So we're going to try to nest some known e-commerce solutions into these different rough categories that I came up with. And last, we're going to delve into decision territory, where I will do my best to try to help you ask the right questions before picking an e-commerce stack. If it ends up being Snipcart, great. If not, no biggie. Let's begin. I like to think of modern e-commerce as a beautiful mess, where there is a lot of fragmentation in functionality. Here's what I mean. When you look at different e-commerce solutions, you'll see that in one way or another, they're solving for these functionalities. So we have website design that's much more high level, that's much more visual. You have content management. Say, for instance, that you have a content marketing or SEO strategy that comes with your e-commerce site. You're going to need to create some articles, optimize them, that kind of stuff. Product management is about inventory, SKUs, the stocks, the product options, defining and managing all of the actual things that you are selling. Cart and checkout, here we are closer to the money. We're in a shopping cart experience online where you can add, remove products, change options, insert a discount promotion, something like that. And of course, go through a checkout where you can accept and process payments securely on your website. Last bit of functionality is store management. And what we mean by that is all of the operations behind the scenes that as a merchant you'll have to do. So managing orders, fulfilling them, contacting customers, defining shipping methods and rates, managing taxes, retrieving abandoned carts. There's a whole suite of things to do behind the scenes. If we were to position these functionalities on a general to specific axis, we'd get something like this, where website design is more general, not necessarily e-commerce specific, and store management is very much e-commerce specific. Now, let us just take a look at the different paradigms, the different approaches that I mentioned. We have three, remember? Monolithic, JAMstack, and Headless. Okay, before you say anything, there are overlaps between JAMstack and Headless. I'll try to cover them in a bit, but you can see here that monolithic approach is a much more bigger one. So let's explain what we mean by this graph. Okay, the monolithic paradigm. If we were to give it a working definition, it could look something like this. Centralizing website and e-commerce concerns into one system. We'll explore solutions later, but for now, if you think about a traditional Shopify setup, it would fit the bill here in this approach. Now, if we wanted to look at the architecture of that approach, it's quite simple. As you can see, you have developers and editors that are working on an e-commerce CMS. And that part is very chunky, right? It takes a lot of real estate in that architecture graph. Why? Because it manages basically everything. All of the functionalities that we saw earlier are embedded into that monolithic platform. Okay, headless now as a paradigm. Working definition here could look like separating product and order management from any customer-facing front end. So what are we doing? We're focusing on decoupling data from presentation, and we do this by adding using an API layer in between both parts. Let's see. Here we go. So here there are more moving parts in our headless architecture. And that headless approach is driven by modern tooling, becoming more and more popular and just available, but also by merchants who are becoming more sensitive to performance and what it means for their dollar bills, and maybe less warm to the idea of vendor lock-in. And maybe also they want to sell on different channels. They want to espouse that omni-channel approach where you can sell from one single place into different customer touch points, as we're seeing here, right? So in the graph, in the architecture graph, you still have developers and editors collaborating and having input into two different tools here. More often than not, you'll have an e-commerce backend. Think about Shopify headless, commerce layer, BigCommerce headless. These could fit the bill here. And then more often than not, it will be paired with a headless CMS like Strapi, Contentful, Sanity, Nadeau CMS, all of these players. Why? Because these headless CMSs are better at managing an actual marketing site. And the e-commerce backend is better at managing an actual store, an actual e-commerce operation. So paired together in a headless manner, they often go hand in hand. You have your API layer where the data that lives inside of the e-commerce backend and Headless CMS will be translated into some kind of a JSON format, for instance, that can be then interpreted further down at the content consumption level, where you can push that information towards Internet of Things, touch points, a web application, a mobile application, and so on. So the headless approach is the trendiest these days for good reasons. It has benefits, right? Just in terms of developer experience, you get a lot of more customization and flexibility. You get also portable backends and data where the front ends can be swapped for newer or better technologies that you find along the way. Of course, the multi-platform shopping experience also is a big plus, especially for bigger e-commerce players that really want to do a omni-channel digital fancy experience where you can have the same user journey flow and purchase through different touch points and all that. And you can use the JAMstack tooling. So, moving on. The JAMstack approach now. The working definition will resemble the headless one with some details being different. So, let's say we define this by separating concerns, focusing on fast front ends, and making e-commerce data more portable. So now the focus here really is on front end and performance, as is the JAMstack in general. You'll see an emphasis on using statically generated assets, which are a core component of the JAMstack philosophy. It really is a best tool for the jobs approach to e-commerce. So in that sense, there is no prescribed architecture here. I would say that modularity is king, and you as a developer mix and match the elements you need in there to create your JAMstack e-commerce. Okay, moving on, we have categories up next. So what have we seen thus far? We've seen the different functionalities that you can solve for in e-commerce. You've seen the approaches you can take to solve for them. And now you'll see the categories of e-commerce solutions that can help you do all of that. E-commerce categories. Okay, so let me first preface this by saying that we see monolith here again. And it's just that it's a paradigm, a monolithic approach, but it kind of becomes a category because some tools are built as monoliths to do a monolithic approach. And be it a traditional Shopify or something you could build yourself, right? Or a more traditional Magento thing, for instance. So monolith is one of the categories. Some of the well-known players, you have Shopify, BigCommerce, Magento, PrestaShop, Webflow, and many others. Add-on is another category that's quite popular and that has a longer track record, in which you can find solutions like WooCommerce, Gumroad, Shopify's Buy Button, Snipcart, Foxy. The storefront is a newer category in which you can find solutions like Shogun, Vue Storefront, Front Commerce, React Storefront. And last but not least, newer-ish category too is the API e-commerce API. You can find solutions in there like Commerce Layer, Nacelle, Commerce.js, Saleor, Swell, and many others. So let's see which kind of functionalities they solve for and some real-life examples. Okay, this is the disclaimer. The categories I just showed you, of course, there are overlaps between them, and I'm happy to address these in the chat or in the Q&A. And just to give you examples, Shopify and BigCommerce, monoliths at first can now be used headless, of course. WooCommerce, you could argue that it also handles your WordPress storefront. Commerce Layer, even though it's a backend e-commerce API, also comes paired with beautiful React components that you can use in the storefronts, and so on, right? The truth is, it's probably smart to position yourself as a purely storefront or as an API first e-commerce platform or whatever. But the rest of the functionalities that we've seen, your customers will need to solve for them in one way or another. So what we're seeing is that many new and old solutions will blur the lines between these categories by offering a core X, but some possibilities to easily have Y or Z also. And you'll see, like, let's not name names or whatever, but many of them also come up with a straight up, stitched up monolith approach, where you can use it as monolith, but everything is already separated and you can take out the pieces you don't want. Now, which of these players will remain in a couple of years? I don't know. I'm not an expert. Is this smart product development? I also don't know. What I do know is that it's very exciting to see all of these different ways to solve the age-old now problem of selling online. And something that to keep in mind for everyone is that the e-commerce pie, it's getting bigger by the minute, especially with these uncertain times that we've been living through. So that huge disclaimer out of the way. Back to the monoliths now, the category of monoliths. What do they support in terms of functionality? Everything, right? So website design, cart and checkout management, content management, product management, store management, everything. Let's give an example. Here we have Alfred, a beautiful website that's just mostly built with Shopify, right? So you can go and check it out, but it would be an example of maybe of a monolith. And if they change their tech stack since I did my research or whatever, apologies. You can let me know in the chat. Okay, the add-ons category now. What functionality do they focus on? Well, more often than not, they will take care of product management, of cart and checkout, and store management. So the actual design of the website and the management of its content will be done by other tools. For instance, well, I'll give you the example. For instance, here you have a website that I love called Overview Effect. You should definitely check it out. The stack is an e-commerce add-on, which is Snipcart. The front end and the website like design is Gatsby, it's done in Gatsby. And the backend is the content management is in Nadeau CMS, a beautiful product. Now, storefronts. They will be the tools in this category will be focusing on website design and cart and checkout. That being said, they more often than not will come equipped with API connectors and a way for you to easily pull in data from e-commerce backends so you can display it in their beautiful UX optimized storefronts. A cool example here is Zenith Watches. It runs on Vue Storefront. Vue Storefront is the e-commerce storefront here. Prismic is the headless CMS, and the e-commerce backend here, last time I checked, was Magento 2. Okay, the last and broadest category is APIs, e-commerce APIs. More often than not, they will focus on product management and store management. The website design, content management, and cart and checkout part might be offloaded to different solutions, as some of the ones we've just seen. An example here, Allbirds, which is a very popular e-commerce site, runs on Shopify Headless. So the e-commerce backend is that e-commerce API is Shopify Headless. It's paired with Contentful as a headless CMS to manage the site content. And then in the front, it's mostly a React app. Of course, they're using a whole bunch of tools, but these are key pieces of their stack. Last time I checked. Okay, so what have we seen thus far? We have seen that there are different functionalities in the e-commerce world, and that different approaches and categories of solutions will handle some of these for you, right? So that's all fair. That's all good. But it could remain confusing and a bit paralyzing because it's a lot of information. It's a lot of stuff, different solutions, and you can't read the documentation of all of these and play with all of these before making a decisions. So you have to have like proxies and ways to evaluate your choices. And I hope what follows can help do that. Okay, first, there are some existing resources that let you either filter categories, solutions by categories, with the functionality supported by these categories. This one right here is a resource that I made with a friend. It's available at headlesscommerce.netlify.app. You can go and check it out. It's also open source, so of course I am missing some solutions in there. You can do a pull request and all that stuff on GitHub. There's a link beneath in the footer. This also is a beautiful resource that has been made by the folks at commerce.js, if I'm not mistaken. It kind of lets you filter different categories of tools you can use in an e-commerce stack and lets you kind of pick and build your stack. It's neat, so it's available at headlesscommerce.org. You should check it out. All with that said, we'll move on to the questions to ask yourself as a developer when you want to choose an e-commerce stack. Okay, there are 6 main questions to ask. The first one is about developer experience. It's fun, it's cool, it's nice to have fancy new tools that you love that that make your workflow faster and less error prone and whatever, right? But at the end of the day, this e-commerce project isn't about you, it's about the merchant, right? So you just want to make sure that you want to check yourself. You want to make sure that DX isn't weighing too heavily in your decision. So that's a good advice to keep in mind. Okay, the second question you want to ask yourself is about this famous omni-channel thing, multi-platform thing. So the question becomes, what touch points do I need to be selling on? If you have a physical component in your e-commerce project and the merchant needs to be selling in fancy events with interactivity and all of that, maybe consider using a purely headless approach where you will have one single source of truth that can be passed into different channels of transactions, right? But ask that question. And the reverse is also true. Do I really need to sell on all of these funky channels? If the answer is not, maybe don't go so hard on the headless thing or on that part of the pitch. Third question is about third parties. So you are a developer or a web designer, you have skills, you kind of know where you can add the most value. So you need to identify that and then identify the places where your value add could be shaky, let's say. And these places you want to offload to existing third parties, be they SaaS, open source projects and libraries, whatever. And when you do that exercise, always try to keep in mind this heuristic of my time versus my client's dime, time versus dime, right? So what are the benefits, but what are the costs? This is something you have to think about when you choose an e-commerce stack. The 3 last questions are about site management. The first of the 3 last is about site management. So, okay, there will be people involved in an e-commerce project, right? Marketers, e-commerce managers, maybe social media specialists, ad expert, beautiful people. You want to make sure that the e-commerce stack you're bundling together or just picking lets them do their work the best they can. You don't want them to be always reliant on you to do trivial or basic stuff that needs to be done. So think about these people too involved in the project. SEO is more often than not an important factor in e-commerce. You want that sweet organic traffic coming from Google. So you have to make sure the e-commerce stack you're picking lets you and or marketers easily optimize and define these meta tags, and that the front end it loads quickly and is secure, and it's pre-rendered, if easily crawlable, let's just say, all of that. So SEO is a big one. And then the last one that I really like, and I called ops scalability, is about you passing the ball. Ask that question: will there be other developers working on this? When? Other agencies? Are they as fluent in the languages and frameworks I chose as me? Is the technology I picked well documented? Does it have a strong community? Does it have an empirical track record of e-commerce success? So this is very important, because you don't want to be the single point of failure of an e-commerce project. And last but not least, when you have to pick an e-commerce stack, do your research. Developers love to read the manual to get their hands dirty, so do it, right? Of course, your mileage may vary here, but there are different ways where you can get information and get these proxies that will help you make a decision. So communities is one. Join Slacks and Discords and whatnot. There are forums or subreddits, for instance, where you can go ask for guidance, where passionate people dwell and reply in comments and whatnot. You can ask the teams directly too. For instance, if you write to Snipcart about hesitation you have, we'll be happy to chat with you. And most of the SaaS and tools out there, the teams behind these are passionate people, and they love to chat with you. You have tutorials, like hundreds, if not thousands of tutorials out there. Just Google for them or go on YouTube or Twitch. There are lots of educational content you can consume. Look for social proof. So in your network, are there people that you know and respect that are using that technology? Or have you seen e-commerce projects that you like and respect and are inspired by that have used that technology, right? Look for these cues of social proof. And then starters, if you want to go more hands-on, most of the e-commerce solutions that I mentioned in this talk, they all have some easy way to get started, right? Where you can build a demo site or a working e-commerce site just with a CLI or deployed to Netlify or Vercel or whatever. So just do it and then see how the DX feels, see what the end result of content management would feel for a marketer. These are ways to do research. Now we're moving into the shameless plug territory. Okay, so let's say you think the add-on category sounds very interesting for your project. If so, here's my shameless plug. Maybe you should use Snipcart. Snipcart is injected into your site via JavaScript, and the products are created as HTML elements on which you add some markup. And we do indulge security. You can change prices in DevTools. We do a crawlback for that. Happy to answer more in the chat. But if you consider Snipcart, just consider this: when to use Snipcart. So our users, they're mostly freelancers, agencies, and in-house developers working with small and medium businesses. They use it to sell quickly or to build custom experience. That's kind of our spectrum of usage of Snipcart. I'm humble enough to say that sometimes maybe you shouldn't use Snipcart. So if you have a lot of enterprise requirements, if you want to build marketplaces, if you want to sell on a lot of different touch points, maybe it's not the best fit right now. However, if you want to do authentic web and mobile stores that don't look like templates, if you want to really own and choose the stack you work with and then just add e-commerce on top, if you want to keep an existing website, if you're working with SMBs, those are all great reasons to use Snipcart. Let me end on a weird note, which is clients and merchants, they don't care about your stack, right? So we've been talking about stack a lot in this talk, and that's just fine. But at the end of the day, if you're not using Shopify or WooCommerce, for instance, your going to be going against a lot of brand recognition and a lot of top of mindedness in the heads of merchants when it comes to these pillars of our community, of our e-commerce community. And that's fine. It's just that if you're convinced that the stack you want to use is different from that, turn the technical features that you love into tangible benefits. Speak the merchant language, right? That will help get your stack accepted. And yeah, maybe clients don't care about your stack, but I do care about your stack a lot. I've been doing this for 8 years now. I love learning about it. I love trading notes. So you should definitely reach out to me. I can recommend whatever. We're independent and profitable at Snipcart, so I don't have to pitch my own thing all the time. Yeah, so please do reach out. I love to chat about that stuff. I'm at Francois at snipcart.com. I'm at THE_FLN, D_FLN on Twitter. And you can also hit me up on LinkedIn if you want to be more corporate. That is it for me, folks. It's been a blast to share all of these ideas with you. I look forward to seeing all of the great content that comes from the Strapi community and Strapi conference. Thanks for having me.
That was such a good talk, Francois. E-commerce is definitely something I think we should all buy into. Wait, I've got something for this. Yeah, it sucks that I can't make crappy jokes for you all in person, so I have to use a laugh track. But anyway, I really loved your talk, Francois. And we're really getting into the talks now, and I hope you're all having fun. Oh my gosh, what is that? I'm so sorry. At least you know it's live. But yeah, this is just a reminder to ask all your questions in the Discord. And in case you missed anything, we're on the Integrate track, and I'm your digital assistant, Daniel. And staying on the topic of e-commerce, I have a really cool talk up next titled Enriching Commerce Data in Headless Architecture. This talk is presented by Roy Derks from Saleor. Roy, the floor actually mean our screens are yours. Take it away.
Great to be here today at StrapiConf. I hope everyone enjoyed so far. So my talk today is going to be about enriching headless commerce architectures. So what is this talk going to be about? So for the coming, I think around 30 minutes, I'm going to be telling you about how you can use Strapi together with other services. And in order to understand what kind of services those are, let's have a look. So you might be in an opportunity where you already have a CMS and hopefully built with Strapi, but you also want an e-commerce store. And you maybe see many bloggers doing this. So they start out with blogging. They have a cool CMS for this. They create lots of content, but at some point they want to monetize this. And the best way to monetize this is probably by also adding some e-commerce to it. So this could be you. But what could also be you is that you're at a point that you already have an e-commerce store, but you want to enrich the data with other data. And I think you can see this already by customers, because they usually, if you're in e-commerce, then you know customers want more and more information about products. They want to have an experience. They want to see what else is possible. They want to have all sorts of data that regularly an e-commerce platform can't give you. But luckily, you can have both. And I'll be telling you how to do this later on. But to give you a small glimpse of what might happen, we're going to be using GraphQL for this. And why GraphQL? That's something I will tell you later. But first, let's head over to learn a bit more about me. Because if you're going to be listening to me for the next time, then you especially need to know who I am. So as already said, my name is Roy. I live in Amsterdam, and you can find me on Twitter using the handle @GetHackTeam. So currently I work for a company called Vanderbron, and what they're doing is selling renewable energy across the Netherlands. And over there we use lots of cool technologies such as React, TypeScript, but also GraphQL. And one of the reasons I'm an ambassador to Saleor is because I really love GraphQL. But besides that, I've been in e-commerce almost my entire life. Starting out when I was around 14, I started my first e-commerce store built with OpenCart, which is a nice platform, also open source, using PHP, HTML, jQuery, like all the things that used to be really cool. But today people are asking more, and I think that's why Saleor might be a good choice for you as well if you're looking to get into the e-commerce world. If you want to learn a bit more about me, make sure to also find me on YouTube. If you would search my name, you can find all sorts of talks. mostly about technologies like React, TypeScript, and also GraphQL, which you can also see by looking at the books that are written. And in these books, I've built all sorts of sample projects, and I believe some of them also use Strapi. So if you're starting to learn Strapi, make sure to also get these books. And if not, let's learn more about how to use Strapi with order tools. And to look at those order tools, I'm going to be telling you more about Saleor. So what actually is Saleor? I already gave away that Saleor is open source, and it's also headless, just as Strapi is. So Saleor is an open source API first or headless e-commerce store. And with Saleor, you can build e-commerce stores yourself. So you already see lots of companies doing this. So companies, agencies, and also people working in the open source field. So far, they've really been adopting Saleor. I believe it's the biggest GitHub repository or the biggest start GitHub repository in the e-commerce sector. So I think that's especially showing how big Saleor is nowadays. And of course, because it's open source, it's really easy to extend, to build new tools on it. And to tell you a bit more, it's also headless and it's using a modern stack. So for those who want to know, on the back end, it's using Python, and they've got all sorts of e-commerce starter stores for the front end built with React.js and Next.js. And of course, it's using GraphQL. So GraphQL is especially a big plus for me. And with it being API first, GraphQL is a nice addition. And I already told you it's headless, and it's going to be really important for the rest of this talk. So it is headless, and it's using GraphQL. So these two things are especially important to understand before doing this talk, because by using these technologies, being headless but also using GraphQL, mean it can easily be extended or combined with other architectures. And Strapi is one of those examples. So if we're looking at this slide, you can see we can use Saleor together with Strapi based on GraphQL. And as you might know, GraphQL doesn't come built in with Strapi, but it's easily being installed just by running one simple command. And with that, you can just use GraphQL all over your Strapi APIs. And Saleor is API first and also based on GraphQL, so we don't need to install anything extra for that one. But how are we going to be combining those two things? We know they're both using GraphQL, or they could use GraphQL, but how can you actually combine several tools or services using GraphQL? And the answer to that is schema stitching. And schema stitching is not the only answer to this, because you might have heard for something called Apollo federations. But I'll be not really asking, but I'm going to be showing you more about Apollo federations later on. But for now, we're going to be focusing on schema stitching. And schema stitching was actually one of the first ways to combine GraphQL schemas together. And then Apollo came up with federations and he actually ditched the project. But luckily, there was a company called The Guild, and they brought it back to life. And actually, they brought back to life the entire GraphQL tools project, which they're now maintaining, and which is also all open source. And here is also the ability to stitch multiple GraphQL schemas together using schema stitching. So schema stitching will let you do this. So at the top, you can see we have a query in Saleor, which is used to get products information like a title and a price. And then we have a query defined in Strapi. So if you install GraphQL and add it to Strapi, you can send queries to it. And queries can be used to get content type collections, such as post maybe, or maybe products, or whatever you like to call them. And you can query them after installing GraphQL. And with schema stitching, we can combine two queries, or not really combine it to queries, but combine it to schemas to be able to send queries like you can see on the right. So we can actually send a query that gets information about both Saleor and also from Strapi. And we're going to be doing this later on using React and Next.js, and of course also GraphQL. So how does this work? So you can see at the top, we have a query for Saleor, which is getting products information. And then we have a query for Strapi, which is getting information about post, or more detailed information like a description. So using schema stitching, we can send a query that combines the two and actually gets the data for both sources. And by combining these schemas, we're sort of stitching them together because we can define what fields should be merged, what fields shouldn't be merged, and how the data will look like. So you can actually even transform or normalize the data. And this is something that you can do using schema stitching. So there are several advantages to doing schema stitching opposed to Apollo Federation, which I'll tell you later on. And maybe what you could also do is just sending queries to both sources. So sending a query to Strapi, sending a query to Saleor, combine the results and displaying that to your users. But there are several advantages of using schema stitching. And I think the biggest advantage is using one unified schema. So if you have users for your API, maybe third party that are using your API, or maybe customers that are using your API directly, you can deliver them one unified schema. And for them, it's a really nice way to introspect what's going on in your data, what are the possibilities, and what do you want to be able to show to your users. And what's also nice to see is that there are merged types. So all the types from content in Strapi will be merged with types from content in Saleor. And this is a really cool feature because if you're using something like GraphQL Code Generator on the front end, which by the way is maintained by the same company that maintains schema stitching, then it's also a really nice example because maybe you're already using React, just I'm going to be showing you later on the demo. And with GraphQL Code Generator, you can use your GraphQL schema to create TypeScript types if you also use TypeScript together with GraphQL and React. So having these merged types and having one unified schema is really helping you to auto-generate code using the GraphQL API. And of course, also data normalization. So if you're bringing back together data from two different schemas, you probably also want to normalize the data a bit in order to be, in order to have data that is unified but also normalized, so you don't have to clean up all these things in your front end. So these are three advantages, but there are way more advantages, of course. So make sure to really check out the documentation and see what else is there to offer by schema stitching and especially GraphQL tools. And what's also nice to tell you is we can do all this from sort of the client. So we're going to be using GraphQL tools, which is an open source library maintained by the Guild, and also Next.js, which is also open source. And using these two technologies, we're going to be sort of doing things client-side. So you don't really building an API, although we are going to be using Next.js API routes. But that's something to worry about later. And so let me try and let's look at some code. And for this, I've created this GitHub repository that you can find on this page. I'm going to be sharing a QR code with you later on, which you can easily scan with your phone or just go to this URL if you're behind a computer right now. So yeah, let's look at some code. So like I told you, I just created a simple Next.js application that's has some basic data in there, and it's using this basic index.js. It's really gonna display the starter Next.js project. So this would be or up at this page. Let me see if it's running. No, so I probably just need to start it run using the yarn dev command. But this will start my Next.js project. So let me go to the browser and probably we'll see something happening here. Be reloaded just to be sure. Yeah, so it's just a sample Next.js product that's just helping you to get started. And in here, as I told you, we're going to be doing things from the client. So what I've done, I'm going to be using API routes. And API routes in Next.js are a nice way to build APIs without having to set up a framework to build APIs. And Next.js is helping you by using these API routes in a way to normalize data, but also to bring backends closer to what you're doing on the front end. So even if you're a front-end developer, or maybe your company is calling you a front-end developer, you can still do full stack just by using API routes in Next.js. And in here, I've also created lots of code already. So let me try and close this a bit. So this is not important right now to understand. So what's important to see right now is that we're using Apollo Server. I'm using Apollo Server for microservices. So this is sort of the smaller package to get Apollo Server and also to create schemas. And if you look here, we can see whatever we return to Next.js is the Apollo Server running on API/GraphQL. And this is something that we can see if we would go here. So don't mind looking at the queries just yet, because it's something we're going to be looking at later. But what I want to do is, I told you, I'm going to be bringing together the GraphQL API from Strapi with Saleor. So the GraphQL API with Strapi, that's something I've set up just by running Strapi locally. And whatever I did there was creating a new product collection, or a content collection actually, called products. I added some information like ID, title. I think I put in description there as well. So this is a very long text. It actually isn't, but it doesn't really matter because we're looking at the demo right now. So I've created this one, and also I'm going to be using the Saleor demo, which is actually the demo environment for Saleor. I could have just set up a separate one, but I think we just as easily to just do it like this. And if you look at Saleor, we can see we enlarge this a bit. So we also have a query to get products information that has an ID and a name and description. And also we have the same thing in Strapi. So in Strapi, we also have a query to get products information. And you already see they look a bit different. So Saleor is using the edges and node concept, or the connection concept that is very suitable for Relay, while Strapi actually has a way more flat GraphQL API structure. So using GraphQL and schema stitching, we're going to be combining the two on an XAS project. And as you see, I already created something, and what's important to see here that I've added a field called Saleor ID to Strapi. So whenever I created my content collection in Strapi, I added a Saleor ID field to it. And this field, it correlates with what we're going to be seeing over here. So my apple juice, not really my banana juice, but with Strapi we can actually really easily add this one. So if we go to localhost, somewhere 3.1, see where it is, it's 1.3.3.7. And it's the admin, of course. So over here I already created, just going to be logging anyway, this is just my password protector trying to protect us. So over here you can see I already add a product. I can add new products, and I believe the Saleor ID is something I can put in here. We can also do banana juice. So just like that, we saved some banana juice, and in our API we can see this should already get in here. Maybe we should publish it, except saving it. Yeah. So you can see in our Strapi CMS, which is running locally, we have some products information that we want to be using together with the information we have in Saleor. So in Saleor we have this products information, and as you just saw, I'm using the ID from Saleor inside Strapi in a new field called Saleor ID. So I think this is a really nice way to combine the two data structures. Something else you could do is maybe use slug for it. So that's something you could do, like having a slug in both and combining it on the one. Or just using the Saleor ID, which I think is the most fault-proof. And then you can see we also have our API route, of course, exposed to an XAS. So let me see how that is set up. So in here you can see I'm using GraphQL tools and Stitch, but also Delegate. But first let's look at the Stitch part and also wrap. Let me clean this up a bit by putting it here. It's very nice. Okay, so what I did over here was creating 3 schemas actually. So one is my local schema, which is used to have cart information. So later on I want to be adding products to a cart. I think it's a bit out of scope for what we'll be showing you today. So let's forget about the local schema. But some other schemas I created was a product schema, which is actually my Saleor demo environment, which I already showed you. So this is having my products from Saleor. And also I've added a schema for my CMS. So this is my Strapi CMS. And over here you can see I'm having my local host, port 1337, where Strapi is running now. And as we just saw, we already added some products to that one. And in here you can see I'm also transforming a bit of the schema that I already have. So all the root fields, which are my queries, mutations, subscriptions, if I have any, they are going to be preceded by Strapi _. So by doing like this, I know that all my main queries or main root fields are from Saleor, and the one with the Strapi that are preceded by Strapi _, those are from Strapi. I'm doing the same one with types. And this is something that you can see in my docs over here. So if we would look here, we can actually already find if we search for Strapi. You can see all the types that are coming from the Strapi GraphQL API, they've been preceded by Strapi underscore. And also my queries and mutations, they are also being preceded by Strapi underscore. So with this, I already have a nice separation of concerns, while I'm still being able to actually combine the two things. So you can see the queries that we did here. So this is a query we can still do here in the combined API. So this is the combined API. We could, an example, have this one for the Saleor products. Also want to put a name here. So this is getting my data from Saleor. And then within the same query, we could also just add products from Strapi. Just do Strapi underscore products. So let's wait for a bit to load. Yeah, so here you can see we have the products information coming from Saleor. So this is Saleor data. This is Strapi data, which of course is obvious because, yeah, the query is being preceded by Strapi underscore. As you can see over here, so here's the data from Strapi coming. So we actually want to combine the two things into one GraphQL query because the schemas, they are now within the same schema, but they're not really stitched together. They're now just two separate schemas being merged together, or not really merged, being actually existing alongside, because everything that comes from Strapi is being preceded by Strapi underscore. And something we're doing here is actually stitching the schema together. So what I've done, I have the three sub-schemas, which are my local schema consisting of my card, which is something that usually lives on the client with Saleor because there isn't a dedicated card query. So that's something you can create on the client, and I decided to create this within an API route actually. So that could be a nice way to, in your application, actually have a card endpoint without having one being supplied by Saleor. But also I have a sub-schema for products, which is my products information coming directly from Saleor, and also my CMS, which is my locally running Strapi CMS. So by stitching the three together, you can see I'm also extending my type definition. So this is extending my schema, and I'm extending the type product, and I'm actually adding a new field to it called CMS metadata, which is actually Strapi products. So this is the products type coming from Strapi. So Strapi has a products type, which we saw in the playground, which is actually this one. So we're doing a query for products. You can see there's a products type. It has all these fields. And whenever we add a new field in the Strapi admin, so if we would add a new field here, maybe description short, description, maybe we want to add something like an introduction, maybe we want to add images, maybe we want to add whatever you can imagine. Whatever we add over here will be added to the type products for Strapi. And whenever we use schema stitching, it will become available over here. So if we would add something like images, maybe we can even add categories. There's all sorts of things you could add right over here. Maybe you want to add promotional stuff. Everything gets over here, and you can see because it has the Strapi product types, which you can see right here. But as we said, we want to stitch the data together. So we want to be able to have a query that is combining data from both Saleor with Strapi together. So we actually want to combine these two queries into one. So we want to do something like, let me copy paste this. So what we want to do actually is something like this. Verify this. So we're getting an error because of course it isn't linked together like this, but what we want to do, we want to get products information from Saleor and we want to enrich it with Strapi. So the Strapi information should become available under a different field. And that's just what I did in the code here by extending the product type in our schema with CMS data. CMS data is the type of Strapi products. And you can see it is a list or an array. This is something nice to clean up later on, but it's based on the way that you can get information from Strapi. So if you want to query Strapi and you want to get a specific product in this example or specific content type, and you want to have something else, then the ID is a filter. You can only getting it by using a list. But that's something to worry about later. So to get the information for this extended type product and this field CMS data, we added a local resolver. It's not really a local resolver, but it's a resolver within my stitch schema. And then here you can see I'm having the product, so product type, which you can see over here. I'm also getting information for the CMS data field, which you can see here. The selection status ID, so I'm getting the ID from my product, which is actually my parent. So the product type, not the Strapi product type, but the product type from Saleor, will be the parent object. And the parent object has the ID, of course. So using the ID, we can just query Strapi using the query we see just right here. And to this we actually add the Saleor ID, which is the product ID coming from Saleor. And something else is going on over here in my browser. So let me get back to the running GraphQL query. And actually my combined query can be found here. So what I'm doing over here, I'm querying multiple things. So I'm querying my card, which is my local schema. It doesn't really matter because we're not using it for today's content. But what we are using is the product query from Saleor, which we'll use to get information about this ID. And over here you can see we're also getting the CMS metadata, which is getting information from Strapi. So we could add more stuff here, like description, and then load it again. And actually what's being done under the hood is what you can see over here. So under the hood, it's sending it's doing a query with Strapi products where Saleor ID is this one. So in our code, you can see whenever we're getting the extended type CMS metadata for product, you can see it's being resolver by delegating the scheme from CMS subschema, which is Strapi. It's doing a query. It's doing a query for Strapi products, the same as here. It's passing some arguments like where, and also Saleor ID matches product ID. So product ID is coming from the parent object, which is of course the type from Saleor. And you can see the same thing over here. So this is the parent. Our ID is over here. Using schema stitching, we're being passed to get data for CMS metadata, which is actually this query. So by doing it like this, we can actually combine Saleor together with Strapi. And I think this is a really nice way for you to enrich your e-commerce store with data from Strapi. But of course, the other way around would also work, because you could stitch the schema from Saleor right into your Strapi CMS data if you're using GraphQL. And as I told you, the full code will be available after this talk. Finding this GitHub repository. So if you find for my name and then go to Saleor Strapi stitching, you can find all the code we just saw and even some more code, because this is just the tip of the iceberg, if I might say. So what do you think? Do you think this is like a nice example for you to try out? And this is something, I also like to hear from you on Twitter. As I told you, my handle is @GetHackTeam. On here you can, send me any question you like. Also about Saleor, but GraphQL, whatever you feel free for. And to also top this off, and I think this will be a popular question, is, so what about Apollo Federation? I already told you that schema stitching was sort of the preceder of Apollo Federations, because Apollo used to maintain the GraphQL Tools library, and schema stitching was part of the GraphQL Tools library. That's no longer the case. And actually, Apollo is using federations as the preferred way of merging or stitching multiple schemas together. And I think federation is very nice, but it's especially nice if you have an active microservice architecture. And if you're working with multiple teams that are maintaining multiple microservices, every microservice has its own schema. And with federation, it's very nice to merge those together. But I think for simpler use cases, or maybe simpler is an understatement, but at least for use cases where you don't really have microservices, you just have two separate services that you want to stitch together, I think schema stitching from GraphQL Tools is a really nice way to get the most out of this. And of course, you could also use Apollo Federation for this. As you saw, we're already using Apollo as a GraphQL server in this example. But I think it's also about what you want to accomplish. So if you want to work together with multiple large groups, use federations. If you want to stitch together to small services quite easily and small I said is maybe an understatement because it depends on your code base, like how big your Strapi or Saleor setup is. But at least schema stitching is a nice, approachable way to really merge those two schemas together, and actually quite powerful as we saw in the code. And as promised, you can also get the code by scanning this QR code. So by scanning this QR code, you can get all the information that we saw in this demo. You can also play around with it yourself. So maybe try and use the Saleor demo that's already being linked. Maybe set up a Strapi of your own. Maybe use your own Strapi setup and actually try and merge those together. And like I told you, this code is being used in a way that Saleor is the main part of information, and Strapi is being used to enrich the data. In this talk, I showed you some examples of how you can also do this the other way around. So you can actually take Strapi as your starting point and then merge Saleor data into your Strapi setup. And this could easily be working if you've already been working with Strapi. But if you want to know more about headless e-commerce architectures, make sure to go to the Saleor website, so that's saleor.io, and also get the code to start playing around with it. And if any questions, find me on Twitter. And if not, then hopefully I'll see you around at some other conference. And I would like to give it back to the next speaker. So thank you for listening. And hopefully we ever meet again. Bye-bye.
Thanks so much, Roy. I always look at talks like this and I'm like, whoa, that is so fancy. But like real talk, it's really good to see Strapi fit into an architecture like that and then gain so much value for your business. And it's so useful. And I'm told we have a break right now. So I think that's done with the first stretch of talks. As always, please tweet us your experiences using the hashtag StrapiConf and drop your favorite emojis in the chat. Feel free to stay and utilize the extra ones we've added. Just as a reminder, we have some amazing sponsors, so please do check out their booths. They have tons of giveaways and tons of value for you to get out of their products. And they're amazing people, so go and chat with them, bother them, ask them all the questions you have, and utilize this break to do whatever you want. Take a trip to the bathroom. I don't know. It's up to you. I'm going to grab myself some tea. See you all soon. Welcome back, everyone. Thanks again for joining us. I'm Daniel, your dedicated digital assistant for the day. Our next talk will be very magical. Pun intended, by the way, and you get to find out why very soon. So give your best clapping emojis in the chat for our next speaker, Maricris, who is a developer advocate at Magic and will be presenting to us a talk titled Gather More Meaningfully with Strapi and Magic.
Hi, everybody. My name is Maricris Bonzo. I am currently advocating for third-party developers at Magic. And I also consider myself a multi-passionate creative, which means I do lots of things on the side, like create content for Instagram and YouTube. And I'm also currently building a community in public called Blockchain Ladies Club. And fun fact, I love creating events and gatherings, but I wasn't really good at it, I realized after reading Priya Parker's book, The Art of Gathering. Well, I wasn't good at making them meaningful. Instead, I was focusing way too much on logistics part of an event rather than creating a unique experience for the attendees. So ever since then, I have been applying everything I've learned from Priya Parker into work meetings and also into my personal life. And now, thanks to JAMstack solutions like Strapi CMS and Magic Auth SDK, I can now turn what I've learned from Priya Parker into something that I can actually use, which is a custom events page. So in my talk, I'm going to go over how I created this custom events page and also share some tips on how to gather more meaningfully. Okay, so this is a high-level view of the events page. We have a Next.js client that is communicating with Strapi, asking for data, and is being authenticated by Magic. So first thing we're going to do is build the Strapi backend. Strapi makes it really easy for us with this CLI command. So once we run it and we get our Strapi backend running, we're going to need to create an admin account. And then this is how the admin panel is going to look. And what we're going to do first is create our own content type. All right, so the content type we're building is events. And as you can see, here are the fields I've added to make up an event. And this is actually what we need to gather more meaningfully. So let's explain each of them real quick. Purpose. So the purpose of your event needs to be disputable. For example, if I am hosting a birthday party and my purpose is to celebrate my 28th birthday, that is too basic. It is indisputable. Instead, a good purpose would be to surround myself with people who bring out the best in me. So this way, I need to question, well, who deserves to be there and who doesn't. Next up is the invites list, and it should be purpose-driven. So for me, I'm gonna need to invite people who bring out the best in me. Up next is primer, and these are just a list of details that you need to send out to your attendees before the event to help them prepare for the event so that they can make the most out of it. Next up are rules, and this is fun because rules help you create a temporary alternative world because it sparks temporary behaviors that embody the purpose of the event. For example, for my birthday, I can make a rule, no phones and no alcohol, so that we can be present and enjoy each other's company in a more meaningful way. Last up is the venue, and you want your venue to embody the purpose of the event and also wake people up from the slumber of their daily routine. So for me, I can choose to have my birthday party at this deserted beach in Santa Cruz. And so it's just going to be me and the people who bring out the best of me and nice scenery to make us all feel happy. So that is all the fields that we've added to our content type events, and it is also what makes up a meaningful event. Now let's use these fields to add an event data. So I did that here and I have published it. Okay, so last thing we need to do, which is important, is enable access to this event data. So we do that by going into the settings panel and go into roles and enable find one and find. All right, now that our events data is ready, let's test it out on Postman. As you can see, I am calling my events API and I'm getting back a forbidden error, which makes sense because we haven't been authenticated to access this events data. So let's do that with Magic. So part 2 is going to show us how. First, we need to create an account with Magic and an app and get the test secret key. Next, we need to follow these list of steps to set up the Strapi plugin Magic. So here we have a plugin that we need to install. And then because we've installed that, we need to rebuild the Strapi backend and run the backend again. And once it boots up the Strapi CMS, you can go to the admin panel and see that the Magic plugin is now visible. So go ahead and paste in your test secret key in here. And last thing we need to do is extend Strapi's default permission policy. And all that means is we're going to create a new file called permissions.js under users permissions/config/policies. And this permissions.js file can be found in Strapi's GitHub repo. And we just copied it and made one tiny change here. We added a try catch block, which is just telling Strapi that once the Magic plugin has been triggered, we call the login with Magic to authenticate the user to access the events API. And that is all we need to do to set up the plugin. And now we need to test that plugin. And to do that, we need a client side. So let's build out the front end. This is going to be really easy because all you need to do is clone my repo. You're just going to need to go into your Magic dashboard and get your Magic test publishable key and also your secret key and paste that into the .env file. And now let's go over the major parts of the repo to understand how we are getting authenticated by Magic and how we're pulling data from our Strapi backend. So in the login page, we are importing the Magic SDK and also this function called get events data. From the Magic SDK, we get the login with Magic link method, which we use to authenticate the user using their email address. And what this returns is a DID token, which pretty much proves that we have been authenticated. And we use that for two things in this file. The first one is for saving the user session in this API call. And the next one is getting the events data from Strapi. So let's see how this function looks like. All right, so this get events data is pretty straightforward. We're pretty much sending a request to our local Strapi backend URL, and we're passing in the DID token to prove that we've been authenticated to get that data, and we're returning that data. Now that we have that data, we can pass it into our events component, which is where we display all of the fields that we created earlier. And we do it in a visually appealing way using React Markdown. All right, so that's when the user logs in. When the user logs out, it's pretty easy. We're going to focus on this API call called logout. And in this file, we are calling Magic's method called logout by issuer. And we're passing in session.issuer. If you look into it, it's actually the DID token of the logged in user. So we are logging out by that DID token. And this logs the user out of all Magic SDK sessions that are open. And we're also calling remove token cookie to make sure that the user session has been removed from the cookies. All right, that is it for setting up the authentication part. Let's test this out. All right, so we are logging in with our email address, and then Magic sends an email to us to prove that we are who we say we are. And here we are. We were able to get the data from Strapi. Awesome. It works. All right, so that's it. I hope you were able to see how easy it was to integrate Strapi with Magic and also to create a custom events page that sparks meaningful events. If you're curious for more, here are all of the resources to my live demos, my repos, and how to deploy your project to production. And if you want to learn more about how to gather more meaningfully, I suggest reading these books. Okay, that is it for my talk. Thank you all so much for watching. And thank you to Team StrapiConf for supporting me throughout this entire journey. And I hope to give another talk at your next conference. All right, I'll catch all of you later. Bye.
That was really magical, yeah. I think that's exactly what we needed to get right back into things. And some very important things were mentioned. I think I'll be ordering the Art of Gathering now. So yeah, I hope you all will too. We'll be moving to our next speaker now, who I'm personally a huge fan of. Up next, we have Liz, who's head of developer relations at NodeSource, who will be giving us a talk on examining observability in Node.js using Strapi. So round of applause for Liz. Questions in the Discord.
Hello all, I am Liz Parody, Head of Developers Relations at NodeSource, and today I will be talking about examining observability in Node.js using Strapi. This is the agenda for today. First, we're going to talk about what is observability, then why is observability important, external tools for observability, benchmark. Finally, we will do a little demo for observing a Strapi app and conclusions at the end. Let's begin by understanding what is observability. Observability is a term from control theory. A simple definition could be is a measure of how well internal states of a system can be inferred by the knowledge of its external outputs. In other words, we see the results or the output, and we can know what's happening inside. Let's take, for example, bananas and avocados. In Colombia, we have a lot of bananas and avocados, and just by looking at the outside, we can know what is on the inside, if they're ripped or if they're not ready for consumption yet. In software products and services, observability means you can answer any questions about what's happening on the inside of a system by observing or asking questions from the outside of a system. We don't need it to ship new code to answer questions, and that's very important. We shouldn't need to write new code to observe what's happening inside of our system or our code. Because system complexity is outpassing our ability to predict what's going to break, there are super useful tools that come to the rescue. Now that you know what observability is, you will be wondering why it is important and why you should care. With environments as complex as we see today in modern applications, simply monitoring for problems is not enough to recognize, find, and fix a number of issues that arise. Sometimes the new issues are unknown unknowns, which are problems you don't know, and even worse, problems you don't know how to find. So without tools to observe the environment, it's almost impossible to solve these issues. This is why observability is important. It gives you the instrumentation you need to understand what's happening in your software and fix it. A good observability tool helps you find what and where the problem is. It doesn't add overhead to your app. We don't want our app to slow down. Quite the opposite. It has enhanced security. We don't want any data breach. Has flexible integration, and doesn't need to modify your code. It's important to differentiate between observability and monitoring. Observing is exposing the internal state to be viewed externally, and monitoring is collecting and displaying the information that has been exposed, and usually involves writing automation tools around that. If you want to solve the most complex Node.js problems such as memory leaks or performance issues, or just follow the best practice to keep your code healthy, it's necessary to have an observability tool. The next step will be choosing an observability tool that adapts the best for our needs. The ability to correctly monitor the process is limited by how much data is exposed. How that data is exposed are the observability tools that we're going to see next. External tools for observability. First, we're going to see New Relic. New Relic is an observability platform built to help engineers create better software. From monoliths to serverless, it helps you to instrument everything, then analyze, troubleshoot, and optimize your entire software stack, all from one place. It also provides different solutions from cloud adoption to digital customer experience, and this is how New Relic insights appear. You can see web transformations time, the application activity, error rate, host, and others. The next one is Datadog. Datadog is a monitoring service for cloud-scale applications, providing monitoring of servers, database, tools, and services through a SaaS-based data analytics platform. With Datadog, you can check requests, latency distributions, error, percentage of time spent, and other metrics of your Node.js applications, as you can see here. The next one is Instana. Instana is an application performance monitor, APM, for microservices. It lets you manage the performance of your applications in real time and see every detail about the inner workings and inner dependencies of your application services. We can see some metrics like calls, error rates, mean latency, top services, processing times, and others. The next one is Dynatrace. Dynatrace produces a software intelligence platform based on artificial intelligence to monitor and optimize applications performance and development, IT infrastructure, and user experience. For Node.js observability, it can tell you the number of processes, CPU and memory usage, the percentage of connectivity and availability, traffic, the most time-consuming requests, and other Node.js metrics. But there is a problem with all of these solutions. The way APM works is they become agents which are intermediaries between your application and the Node.js runtime. The APM is injected into your code and it encapsulates your application so they can extract the information, and that has a significant cost, also known as an overhead. Another problem is that sometimes you have to modify your own code in order to implement the APM. Code instrumentation, which create extra work and a layer of difficulty that we don't want to deal with. Also, accuracy is questionable, but they can be very useful tools that provide you with additional insights and extensive data. Now let's see one tool that doesn't have this problem because it's not an APM. It's an enterprise runtime for Node.js and it adds minimum overhead. I don't have to modify your code at all. NSolid. NSolid is a drop-in alternative for the Node.js runtime, enhanced to deliver low-impact performance insights and a great security for mission-critical Node.js applications. It has faster time resolution and zero code instrumentation. That means you don't have to change your code in order to implement it. This is important because traditional APM tools sit on top of Node.js runtime layer. Performance overhead might vary from one application to the next, depending on the architecture and stack used. Other tools are not built specifically with Node.js in mind. NSolid was built specifically for Node.js. It's a Node.js runtime itself, not an agent. Here we can see how some of the metrics are displayed, like the dashboard where you can see each process, heap use, CPU percentage, and others. It is important to clarify that the previous tool I showed, they all contain libraries that help you expose data, but the main function is as a monitor. For example, I cannot expose data using the New Relic API and consume it via AWS. This is where NSolid has an advantage. The additional metrics NSolid provides can be consumed by any monitoring solutions and without any additional overhead. The best of both worlds. Finally, and now that we have seen some tools for observability, let's see some benchmarkings that compare the most important features for an observability tool. If we're going to check load times, which is the time it takes for a Node.js process to be available to receive and process requests, we can see vanilla Node.js is the fastest with 30 milliseconds, followed by NSolid with 40 milliseconds. Then we can see Instana with 210 milliseconds, which is an increase of 600%. New Relic, Datadog, and finally, AppDynamics, which is an increase of 3,600%. Startup times, we can see that Node.js takes 30 milliseconds in the startup time, followed by NSolid with 35 milliseconds, then 150 and 250 milliseconds by AppDynamics and Datadog, which is an increase of 600%. Adding baggage or memory overhead, NSolid only adds 2 megabytes of memory, while New Relic and Datadog adds 15 and 57 respectively. Finally, measuring speed, NSolid is the fastest one with almost 10,000 requests per second, then AppDynamics with 2,000 RPS and Datadog with 1,500 RPS. Now, let's do a little demo to observe what's happening inside a Strapi app. First, let's just use a Strapi template. I'm going to use the e-commerce one. So I just create the template using the command yarn create Strapi app, folder name, -- template, and the repo URL. I choose the quick start option. Then we wait for a few moments while it installs everything. Then it goes to localhost 1337 and it displays the registration page. I fill all the fields required and I press the Let's Start button. And voila! It shows me the amazing Strapi landing page where we can see a tutorial, blogs, documentations, examples, and of course the Strapi community. Because we use the e-commerce template, if we go to categories, we can see the ID, name, slug, products, and on the right, we can duplicate, edit, and delete categories. If we go to products, we can see all the products with its ID, title, description, price. We can add products and filter them. An amazing user experience, a great CMS. Very easy to customize and create performant content APIs. Then we have content types builder, media library, marketplace, plugins, and others. If we want to observe what's happening in this simple e-commerce API, first we go to the working directory and we connect the process with nSolid using the command export nSolid command localhost 9001. Then we just type nSolid console and go to localhost 6753. We can select the project. We select the process and we will be able to see the important metrics such as CPU use, memory, host load, async data, event loop, and others. And if we want to see other metrics, we just select them. We can take heap snapshots and CPU profiles over here to get greater insights of your Strapi applications. In general, if we take a quick look, we can see that all the metrics are looking good, which means that the Strapi app is highly performant, secure, and reliable. And by far, the easiest and possible the best solution for jumping into the Headless CMS world, and even better as an API framework to power whatever your needs are: web, mobile, desktop, IoT, and others. As a conclusion, observability in Node.js is very important for security and performance. It allows you to fix errors faster, and if you're focusing on Node.js specifically, nSolid is the best observability tool out there. The other tools are great, but they come at a cost because they are noticeable overhead from wrapping the user's code in their own libraries. nSolid avoids this penalty by observing the application at a lower level, allowing nSolid to make observations without directly affecting how the program runs. For other types of applications, and depending on your needs, there are other great observability tools that adds a lot of value. Thank you. Bye.
Really great talk, Liz. Hands up in the chat if you just found out about the concept of observability. It's such a cool concept. And thanks, Liz. Thanks so much for your talk. We've come a long way on the StrapiConf journey, and I just wanted to say how much I really appreciate all of you for joining us. As has already been stated multiple times during the conference already, we could not have done this without you. Hey, so I sort of screwed up the last take and I had to redo this. So thank you so much, Liz. Show of hands in the Discord. How many people just found out about observability? I am definitely one of them. I really loved that talk, Liz. Our next talk is a very, very interesting one. Staying on the theme of integration, we have Andre Eriksson on personalized onboardings with Strapi and Encore. So, a round of applause in the chat for Andre.
Thanks so much. Hey everyone, it's great to be here. My name is Andre, and I'm the founder and CEO of a company called Encore. And I'm here to talk about personalized onboarding with Strapi and Encore. Encore is a backend framework for rapidly creating APIs and distributed systems. And as we were developing this, some of our early customers expressed to us how much of a joy it was to use Encore together with Strapi, where Encore is all about rapidly creating APIs and writing business logic, and Strapi for building a content management system incredibly quickly. This combination was very powerful. And so we recently launched, and now we're focusing a lot on how to onboard new developers onto the platform and activating and engaging with them. And so it was very natural for us to use Encore itself together with Strapi to make this easier. And that's what I'm going to talk about. So what we did was we created an Encore application that uses Strapi for personalized onboarding. And the goal with any personalized onboarding is, well, first of all, it really needs to be inspirational. It needs to inspire people and learn, oh, I could use Encore for this, or Strapi is great for this use case. And we really wanted to educate people because as you're starting to build something, you might not know exactly what features are out there or what you can do. And of course, maybe most important of all, we wanted it to be really welcoming and personalized to exactly the sort of experience you're looking for. So what we did, and you can see here on the right, is a type of example email that we created. And initially we built this just by writing HTML in a code base and sending it off as an email. But this didn't really scale, and we wanted something more visual. And that's where Strapi came in. We started to use Strapi for content management and being able to define not only the emails themselves, but also a whole onboarding series with multiple steps and different conditionals depending on what sort of features you were using. And then we packaged this up in an Encore application with custom business logic that then integrated to fetch the content from Strapi and send it off to our users with Mailgun. And this is how it looks like. We have a user who interacts with our website. That website itself talks to our backend. And as the user interacts, we send off events to our onboarding application that we built with Encore. That application talks to Strapi, where we have ahead of time added content to define the sort of emails and onboarding series that we want to have. And so this is what we built and what I'm going to walk you through today. A very high level look on what our Encore application is doing is it's a very simple API where we send in both events from our users when they're, for example, integrating with a certain feature of our product, as well as notifying it when a new user signs up. And this is how we start the onboarding series. So we have this component called the series tracker, which is taking in all of these events and scheduling the next step in the email series. And we track that in a SQL database. We then have the emailer component, which talks to Mailgun to actually send the emails, which itself interacts with the content fetcher to fetch the content and the email series from Strapi. And so how does this look in terms of the Strapi integration and the data model that we want? On a very high level, it looks like this. We have our series, which in this case is an onboarding series, and we define multiple steps where each step can have a customized delay as well as a series of conditionals that could tell us only send this email if the user hasn't tried a particular feature yet. And each step links to a template, which is a combination of a subject, an HTML body, as well as a plain text body, and this together with images. And these are what we package up into an email and we send off. And just to give you an idea of how this looks like in Strapi, it actually took us a very, very short amount of time to set up. So we have our series and templates, and what we're looking at here is the very first email in the onboarding series. You can see here that Strapi not only makes it incredibly easy to write, but it also gives you this visual interface where you can really get a feeling for what does the email look like when it reaches our users. Once we have defined all of this content and packaged it up in a way that it looks great, we then used Strapi's GraphQL API. And what's really nice about this is we just need these 18 lines of code on the right here to fetch all the data we need. So starting from the series, we can figure out what are the steps involved, what's the delay, what are the templates for each step, the subject, the HTML body, you name it. So we do this in a single API call, and we get all the data we need. And then we can process that in the Encore application and fire off the emails. And it really is that easy. And what was really powerful about this was we started with just defining these HTML templates in code in our code base. But that wasn't really useful, and it didn't let non-technical people interact and improve on the emails. So we had this idea, let's use Strapi for this. And we went from idea to being live in production with this new setup in less than 2 hours. And we now have a much more scalable solution in place to both add more content and use cases, but also be able to iterate and visualize the content without technical people having to do all the heavy lifting. It's a really fast setup, really helps with collaboration, and scales much better than just doing it in code. Perhaps most importantly, we package this up as an open source project. You can check it out. It's really simple and really shows you the power of combining Encore with Strapi. That's it for me. Thank you so much for listening.
Thank you so much, Andre. That was a really, really interesting talk. This is one of those, I didn't know Strapi could do this type of things. And I guess that's the whole point, coming and seeing how Strapi integrates with so many different technologies. Thank you again. And if you have questions for Andre, please put them in the chat. I'm sure he'll be there to answer them. And let's move forward with our next talk. Our next talk is from Chad Carlson. His talk is titled Editorial Workflows, Get Them Here. So it's serious. If you have questions, as usual, for Chad, put them in the Discord. I'm sure he'll be there to answer them even while his talk is going on. That's the beauty of this virtual conference hosted on Discord. So Chad, please take it away.
Thanks a lot, Daniel. Hi, everyone. My name is Chad Carlson, and I am a DevRel engineer from Platform SH, and the title of my talk is going to be Editorial Workflows, Get Them Here. Thank you all for coming. The problem that I became interested in that I wanted to focus on for my talk is how non-developers can adapt to the headless CMS model. The more that I've worked with Strapi and some of the other options out there and just the broader topic of what happens when we go decoupled and headless is that there is a real, maybe a hurdle that happens for editorial teams when they get introduced to something like Strapi. Nothing against Strapi at all, obviously, but they're used to a certain set of tools when they're working with something like a Drupal or WordPress. That's why you see a lot of sites that are going decoupled just ingesting that information in the first place from some of these legacy CMSs, because editorial teams, editors, and authors are really used to using these frameworks. But even when they do, it's going to be a Strapi case or WordPress or Drupal, there are things that they're losing. They're losing some of the review process that they're used to working with. They are also potentially losing the live preview aspects that you're going to get built in with something like Drupal or WordPress. And in many cases, like on Platform SH, when they are being set up on an environment that kind of expects read-only access to the file system to get the kind of repeatable builds that we would want for a strong production Strapi installation, they're not going to be able to make changes to the API in the same way that they might used to be doing. If I'm in a Drupal installation, decoupled or otherwise, I may be able to add new pieces of content, but I could very well add a new collection content type in Drupal, the equivalent for, say, an event. And we'll see in a moment that when we do something like this on Platform SH, it's not always ideal to continue to allow write access to the file system when we want to keep some of these properties of repeatable builds that we might want as developers on the other side of this that doesn't have to do with editorial teams. And so that's a lot of what this talk is about, is how can we in some ways restore the workflow that they're used to without forcing people who aren't familiar with Git from ever really touching Git. And so this talk is meant to be largely experimental. I mean, there's just some things that I've been playing with on Platform SH that sort of try to get to the heart of this. So the first part will go into the choice to decouple in the first place and how GitOps, the sort of model that we follow at Platform and recommend, works with the content management system approach when it's decoupled. And then we're going to go and try and restore a couple of these pieces that we would have in a monolithic approach. So we'll try and get live previews down with Strapi on the back end, pulling into a development server of Gatsby on the front end. We'll also look at what are the challenges in trying to keep something like live preview, but then also allow for an author to write something, an editor to review it, and then for that content to then make it all the way to production. What does the actual publishing cycle look like? And then a smaller one, but like the example I just said, what happens if an editor wants to add an event content type, an event collection? For a production instance of Strapi, no new collections in production. So how do we restore the ability for an editor to do something like that without creating a ticket for a developer? I'm going to move my computer screen a little bit so I can see my slides. So obviously there's plenty of reasons that you would want to go headless. We're all quite familiar with them. We're at StrapiConf. So we're a little bit sold, at least, on the idea of having a separate content store with a tool that makes it really easy to build out an API for this content backend. The goals of decoupling, as far as I can tell, is really on trying to make your API as abstract as possible, so that if you do end up in a position where you're no longer interested in a Gatsby front end, or if you want to add additional heads to your decoupled setup, one for mobile or for some other kind of device, that it's really easy to do that because of this consistent API in the back end. You can isolate teams to focus on the front or the back end only, and it's great. But like I said in my introduction, there are things that we need to consider. If we're abandoning the monolithic approach for something like a Drupal or a WordPress, we're going to lose some of that tooling that comes out of many, many years of people working with those CMSs. We're going to lose some live preview functionality. We're going to need to rewrite it. And we are likely going to have to find a way to get around the fact that most of the changes that an editor or an author are going to want to make on the site to work with a kind of modern development workflow, at least how we see it at Platform, it's going to require us to get around the fact that they're going to have to make those changes in Git. So very, very briefly, so Platform SH is a hosting company for one, but we're a platform as a service company. So we work with hosting your applications on all the big providers that you're already familiar with, AWS and Google Cloud and Azure. But we also provide a collection of DevOps tooling around your existing repository that allows you to do things like add a set of YAML files that provision a Node.js 12 application container based off of a line like you'll see here that's specifically for our Strapi instance. And so that means as a committed part of the repository, we can very easily make a branch, and on that branch, upgrade that to Node 14 and test how that goes for our site. And Platform takes care of provisioning each of those environments for each of the branches or pull requests that you have. And those changes can be version upgrades on languages, on the services that have a very similar configuration, or to your code itself. It just maps the branches one-to-one automatically to your repository, and everything is trackable and highly visible in Git. And so Git becomes the real huge model of our API. Git's the source of truth, and we can tie things like production data on our master branch to this same model. So if I'm branching out for some new feature off of the production branch, I'm going to not just get a replica of the code, all the infrastructure that comes with our configuration files inside a repository, but also all of our production data. So that gives you an interesting way to include some real customer data, some real data in your testing on any of these new feature branches. But there are some caveats. So if you'll see here, this is a configuration file for a Strapi application on platform. We define Node.js 12, and we're going to use Yarn for all of our downloading dependencies and for building our application. So you see here that we have a build hook that's going to do those exact 2 steps to give us the final Strapi app. But then after that point, our container is going to become read-only. The idea here being that you'll see here I have all the frozen lock file flags on here for Yarn. That what is in Git, what is inside of your repository, so what's going to be inside your Yarn lock file alongside all these other pieces of configuration is this highly reproducible build image. So we really don't want a whole lot of write access at deploy time, at runtime, because we want to be able to reproduce this site on any new branch that we open. So we have it read only at runtime. And we'll see, sort of as I've outlined a little bit before, that's going to give us a little bit of a hurdle to come over. The interesting thing that we can also do on platform that's going to come into how we accomplish decoupling in the first place and then allow us to communicate between the 2 applications is that we can define an internal network for our project. So we can have a single repository with subdirectories for each of the apps that we're going to continue to develop. So we can have Strapi in a subdirectory and say Gatsby for the front end on another subdirectory. And then when they deploy, we have our container cluster that has within it itself an internal network that those 2 can communicate with each other on. So in this case, Strapi is going to serve this API that we're going to define out, and then Gatsby can communicate over, I believe I have it here, a relationship. So in the same way that we had a relationship for Strapi to our Postgres database where we're storing all of our actual content, we have another one directed towards the Strapi app container that is going to be accessible for Gatsby. Sorry about that. So, okay, we have this GitOps model. Git's the source of truth. Part of that is data flows down. It's not ever flowing up. The only way that anything can flow up is it has to be code, it has to be committed, and it has to be merged. Everything is tied to this reproducibility idea, and that's really a great system for handling code. But it's going to get into the way of these features that we want. It's going to get in the way of previews, of runtime collection writing, all these things that editorial teams are going to kind of need rewritten from their experience with a monolithic application. So one way that we've done this at Platform is we can define a mount on our file system that does continue to have write access at runtime. And so we've done that as a way to show off this exact thing where we have a Strapi backend on some development branch that we can add new collections to. The problem then is this anything contained within that mount, so this new events collection, rather than our normal articles or blog. We have this second collection called events, isn't going to get committed, so it'll never make it up to production. So how do we get the data up the tree? How do we get a new post up to production? How do we get a new content type that's going to be stuck inside one of these mounts and never actually get committed up to production? And how can we then maybe finagle into there some live preview at the same time? Does it all fit together? And so the point of my talk here is to say, yeah, kind of. Should you do it? I mean, that is completely up to you. It's been an interesting experience playing around with it. So let's look at live preview first of all. Like I said, we're going to have a Gatsby container and a Strapi container in one project. Inside that cluster, there's going to be a relationship from Strapi to Gatsby that it can pull data from the API on. The way that Gatsby allows you to enable something live preview, I'm sure you're all familiar with, is that you can enable this refresh endpoint on Gatsby. It's __ refresh that is going to allow you to ping it, and it will, in our case, rebuild that data layer through that Strapi relationship. Now, enabling this part is going to require us to run a development Gatsby server on our cluster. So usually the way that we approach this is having a sort of development version of our cluster run on non-master environments. And so from there, we can enable the endpoint with this enable Gatsby refresh endpoint equals true environment variable. And then we add, in this case for Strapi, a lifecycle webhook to our content type, to our collection. So in this case, I went too fast. So you see here inside of this snippet, we can modify our start command. So instead of it looking at the built Gatsby site that we've gotten in the post deploy hook and pulled from all of our Strapi content, it's going to run the development server. And from that development server, we can begin to build out this preview functionality between Gatsby and Strapi. So like I said, we have these callbacks set up inside of our model of the article. And so this is throughout the documentation of we can have a couple different events that we want to make sure that we track. Creation, update, and deletion of a entry inside of this article's collection. So in this case, we're going to set a configuration JSON up in our Strapi file structure that is a static website build URL. So this is straight out of the documentation. On Platform SH, the way that we would do this is during any time after the build step, we can pull information like what is the current URL of any of the app containers. And more importantly, we can say what's the current relationship address for the Gatsby container in this case. And so from that, we can kind of build together this refresh endpoint and put it into this configuration file once it's available, and then call it inside of these lifestyle hooks. And so when we get that from that environment variable, we can begin to enable preview. So in this case, I can't go full screen from there. That's odd. So in this case, we have our Gatsby site on the left that has a list of all of our articles. It's labeled blogs in this case, and then that articles collection here on the right. So from here, we have a development server for Gatsby, and then we're going to have these webhooks on the Strapi instance that we can then update the content attribute and have live preview. So this is running on platform, but it's not on our production site. So we're kind of getting away from this total reproducibility because we're having an experience on a development environment that won't ever be in production. But it's going to be one of those things that starts picking away at restoring this editorial workflow for our authors and our editors. And here we go. I can delete and then republish an article and have it refresh on that front-end Gatsby site. Oh, now it's going to restart. So the next one then is, what is the correct way to continue to allow an editor to review an article that has a preview URL now, which is great all by itself. Doesn't always necessarily follow the GitOps model, but we're starting to get around it, that we have this development server so an author can get an assignment and have credentials that are isolated to a work in progress development environment, purely for trying out and writing new posts. And as they add it, they have a preview URL that they can pass along to their editor. Okay, that's great. But at this point, built into Strapi, there's already a published attribute selected, right? I mean, this is a newer feature within Strapi of having a part of a model contain this unpublished publish characteristic. So we need to define something new that'll allow us to identify something as approved that an author doesn't have access to. And then we need to be able, again, to get this data out of a preview, review, development environment and somehow get it back onto the production environment. We can't do that through a merge, because as much as we can create new branches and pull data from production into any of those branches, and we can continue to sync from production too, we can't get it upstream. That's not how this GitUps model works. So how do we get it upstream? So the way that I started playing around with it is I created a new collection type, poorly named toMasters. So what this ends up becoming is a relationship attribute for every article. And so the collection itself isn't accessible by anybody but an editor. And then editors can get this new preview URL and say, yeah, this looks good. I'm done with my feedback in my nitpicks. I like how the preview looks, so I want to publish this. And they essentially just binary choice, set it to master true. And then that feature is going to be kind of a filter as we extend out this after update lifecycle hook. So this is what I've been playing the most with, because it's sort of the most against our model, but the most interesting, and with as many edge cases and gotchas that I can potentially foresee, but still interesting to play with. So what I ended up doing is this after update lifecycle hook is going to include a result of the update itself, and then we're going to feed it into this front end refresh call, same as always, because we're still on a development environment. But then we're going to get all the data that we sent to Gatsby. Gatsby doesn't require any data on its refresh. It's going to do that itself, but it's still going to be included in Strapi's request. So what I was playing around with, and I got working decently well, was checking for this toMaster attribute, trying to determine if it has indeed been approved, if a relationship has been defined between, if a relation has been defined between a toMaster and an article. And then from there, I'm kind of just rebuilding the article and recreating it on the production environment. So, of course, this is highly simplified, because in playing around with it, and as you'll see here, there's nothing in here of permissions or of anything specific for certain environments, not others. This is a purely public API that is only set to do this from any development environment. And we might want a little bit more granularity than that, and it's going to create edge cases because it's so generic. But you'll see here, I'm going to grab the image, a bunch of these required fields that I've set for an article. I'm going to grab the image for the new entry and pull from the environment some variables about the production Strapi instance. So in this case, the way I've implemented this is, it's not something that will necessarily be dynamic. We want a project-wide variable that points to our production backend instance of Strapi. And so I can pull that from the environment and then build a multi-part request to post the image resource to the upload endpoint of that production instance. And then using the response from that, I'm going to get that image ID and then just recreate an article. It's the same article on my development branch that's been approved and has been looked over by our editorial team, by our editor, and it's just reposted to the production instance. Kind of messy, not great. And there are other parts to it too. As much as this may work, it's going to have edge cases, and beyond that, it's not going to result necessarily in an instant publishing of the new article. The way that Platform SH works, especially when we're talking about this production environment, we want a full Gatsby build, not one of these development instances, a development server at Gatsby. So we're still going to need to have some other additional call that's going to tell Platform to rebuild Gatsby on the production branch, because it's not going to do the same refresh that we have on these development environments. But at the very least, we can wait till the next time that something gets merged into production, and then we'll just have that as a loose publishing date. Or otherwise, we'll see in a second that we have another feature that we call source operations, where you can make like a very small edit to the code that forces a rebuild, in which case that would create a publishing event. But either way, the data has gone from this preview environment onto the production environment. Yeah, that was interesting to play with. Obviously, it has holes. It's going to have things that need to be accounted for, not just for permissions, but what happens if I want to update that same post, or what if I want to delete, retract a post that has made its way onto production. But interesting to play with and how you would do it around our sort of GitOps workflow. So the final one is the smaller use case that I can see. Editor interested in having something new show up on the site. I know at Platform, we don't just have blogs that we're writing, but we have events like these where we're talking, and our DevRel team and marketing team are involved with. And we want some visibility on our site for that. So if we were doing it in a decoupled manner, we want editors to be able to play around with what they want in that data so that they can pass that all along to a developer and have them presented in a nice way. So again, production can't do that for Strapi. But once we've set up a development server for Gatsby on a development environment, we can kind of see the route that we're going. We could set up a development server for Strapi there too, and allow some of this runtime access to, a runtime write access to the file system in the same way that we have for Gatsby. So we can do that, but then it won't be committed, any new collection that we create, and it won't go up the tree. We can define our API subdirectory to have write access with one of these mounts. I don't think I showed you what that syntax looked like in the previous slides. But then we could use what I said before, a source operation. So it looks something like this. It exists in the same application configuration file I showed before, but in this case, it's going to use our existing CLI commands to connect to the environment that we're on in this kind of set-aside build container environment. And in that container, it's going to go, I want to sync everything, and then I want to download everything that's currently on this mountain that's not going to be committed. And once I have that, I'm going to stage and commit it inside this little build container. And then it will actually allow you to apply that commit to this development Strapi instance. And so, there's some workarounds that you need to do to make sure that that doesn't get written over by the subsequent deployment on that development server. But at the end of the day, you're going to have something that still has write access, but it has this new collection in this mount that actually will get committed and make its way up to production, or make its way up to another development environment that a front-end developer can start to play around with to see how that's going to actually be shown on the site. I guess I just wanted to show a quick preview of this terrible video. Anyways, it has two components to it: running the actual source operation itself, and then pushing to staging, pushing that actual commit to staging. And so, should you do it this way? I'm not sure. Probably not, but it is interesting to see that if you thought about all these edge cases long enough, you really could end up with a situation where you have some of the most efficient tools at your disposal for having a lot of assurance for repeatable builds for your production environment of both Strapi and some front-end consuming head, but that you can start to piece together with some of these lifestyle webhooks and tools like source operations on our side and some environment dependent development server business, for lack of a better word, some environment dependent differences in how each of these servers run to kind of restore a lot of this editorial workflow that your teams are going to be used to working with, so that devs can be happy and they can have their own little side workflow that's specific to dealing with the front end, and that the editorial team itself can be on this other tree completely involved in content. They don't run into each other, and hopefully not a whole lot of conflicts when they merge into production. Thank you very, very much for joining me for my talk. I hope that it was at least interesting in the little bit of experimentation we've been doing at Platform SH with our multi-app configuration. We're going to be having a workshop later on in this week as well. But either way, thank you for coming, and take care of yourselves.
I get asked this a lot, so I just want to say, Chad, thank you so much. Now I have a talk that I can send to everyone whenever they ask about, Git workflows. So let's show some love for Chad in the comments. Let's send like a clapping emoji, some hearts. It was a really, really good talk. Followed by which, let's make some noise with our keyboards, of course, for Bolaji, our next speaker, who is a developer advocate at Commerce Layer and will be giving us a talk on doing e-commerce right. No, he will be giving us a talk titled E-commerce Done Right with Commerce Layer. Round of applause in the chat for Bolaji. Take it away.
Thank you so much, Daniel. Hello, everyone. Good day. It's been a long while since we interacted at physical events, but thanks to amazing folks like the Strapi team who keep bringing us together to connect, irrespective of all that's happening in the world today. My name is Bolaji Ayodeji, and I am a developer advocate at Commerce Layer. So what I do is I stand as a mediator between my company and developers using our products. I try to help developers be successful with our products and their craft generally. I do this by building tools, demos, integrations, open source projects, and documentation. Alongside my work as a developer advocate, I am passionate about sharing knowledge. I do this a lot on my blog and on my newsletter. I'm also passionate about web engineering, JAMstack, communities, and open source. Feel free to reach out to me on Twitter at IamBolajiAyo and maybe tweet one or two things about this talk so my manager thinks I did a great job. All right. In 2019, a study by Maricris found out that more than 227 million Americans shop online. Wow. Now, this number was expected to increase in the coming years before a global pandemic forced shoppers to, shop online for essentials. The truth is, more technologies are rising, more stores are erupting, and consumers now shop on more devices. There is hence a need for businesses to adapt to emerging technologies, competitions, and increasing customer demands. Failure to meet up with these demands will lead to unsatisfied customers, which will in turn affect conversions and sales. Today, I'll be talking about headless commerce and how to do it right with Commerce Layer amidst the rapid evolution of digital commerce. All right, so this is pretty much what we're talking about today, but let's just skip this and go right into the talk. So yes, let's start with traditional e-commerce. When we talk about traditional, we mean all e-commerce platforms that were launched 10 years ago or more. Now, traditional e-commerce platforms are built on an architecture called the monolithic architecture. And this is a way of designing software where all the components are built into one independent and deployable application. So Those components can include the presentation layer, the database, the business logic, content management system, and much more. So this is just how a traditional e-commerce platform looks like. You have the UI on one end, you have all other components behind it, and every single thing is just in one deployable application. Now, every component or decision made in the development of e-commerce platforms is aimed at satisfying customers. And this is why every engineering decision you make is directly proportional to the business goal of your e-commerce platform. And this is one thing most e-commerce businesses today miss. You hear some e-commerce businesses say, well, my platform is fine, my business is okay, I make some sales, my customers are happy, and all that stuff. But the truth is, the needs of your customers are increasing daily, the same way technologies are increasing daily. So there's a need for you to review your technical logic behind your commerce and see how that logic is satisfying your users. So it's possible that what you have now is serving your users, but there's probably a better way for you to do that, because every single day there is something new coming up. There is more demands coming from your consumers, and you really need to level up and be up to date with whatever demands is coming from your users. Now, three major factors affect the success of e-commerce businesses. One is performance, and this depicts how fast users can access and interact with content on your platform. Next is scalability. Now, you also need to maintain high performance as your traffic increases, right? And the last factor is user experience. And this depicts how satisfied your users are when they interact or engage with your platform. So throughout this talk, we are going to be reviewing what e-commerce was many years ago and how it is now, with respect to these factors and how they affect customer satisfaction and business growth. So yeah, now that we know what traditional commerce is, let's take a look at some of the challenges faced with traditional commerce. So generally, traditional e-commerce solution is limited. I mean, it fails to satisfy the evolving needs of 21st century customers. 21st century customers want things fast. They want better user experience and a lot more. But the traditional e-commerce solution doesn't give the technical logic required to satisfy customers. And so some of the challenges traditional commerce encountered include speed and flexibility. Like I mentioned earlier, a traditional e-commerce platform is built on a monolithic architecture. And this architecture couples several components into one deployable application, which means there's going to be a large code base, and this large code base will require high processing time. This can lead to slow load speed time while deploying your applications and in production. Eventually, you have several teams working on your application, and they all need to collaborate. But with a large complex system, it's going to be hard for them to understand the moving parts of the application. The complexity of the application can also lead to ID overload, which would also affect build time. And eventually it affects the productivity of developers. And the most important thing about this flaw is that it becomes hard for developers to test new ideas, to adopt emerging technologies and try to, implement them into your application. The next challenge is cost and scalability. Building an e-commerce platform traditionally takes a lot of time and it takes a lot of engineering resources. Any single change you make to even one component in the application affects the entire application. You have to redeploy the entire application. One of the goals of businesses is to to grow. You want to make more revenue. You want to, get more customers. And while your business grow, your customer base would also grow. So there's a need for you to make sure your platform is efficient as it is when you had fewer customers, now that you have more customers. But the problem is with traditional commerce, it's harder for you to scale one component of your application because There will be several requirements of each of these components. One component in your application might require you to scale horizontally, while another might require you to scale vertically. But because all these components are in one application, you really cannot make any change to all of them individually. So you have to upgrade the entire application. And remember, any form of upgrade you make literally just affects the entire application, and you need to retest and redeploy. This is not so cool. The next is security and reliability. So security happens to be one of the most significant concerns in software engineering. And if for any reason a security issue arises in just one component of your application, either due to memory leak or an attack, the entire application is vulnerable and it's prone to attack. So this also makes it hard for you to detect where this attack is coming from or detect where the issue is coming from and try to fix it, because it's a large application and debugging becomes much more harder. In the long run, when you eventually figure out what the problem is, you still have to go through the same cycle of bundling and redeploying the entire application, and this is not so reliable. And the last challenge I'll talk about today is modularity. With traditional commerce, it's hard to practice structured programming. Modularity allows developers to encapsulate code functionalities into modules that can be reused in other components. But with traditional commerce, it's really hard for you to do that because you can't just have modules in the traditional commerce platform. And this way it becomes harder for developers to test new features or to rely on reusable modules or to even build new features faster, because now they have to literally build everything from scratch. Now that we've understood the challenges that exist with traditional commerce, I'm sure now you might be wondering, okay, this exists, so what do we do? There needs to be a solution. And this brings us down to headless commerce. But before we delve into headless commerce, I would like us to understand the concept of headless, which is a very popular term in software engineering. So headless is a concept that implies that a computer software functions without a graphical user interface. And what this means is the functionalities powering the application are independent of the user interface being displayed to end users. And there's like an intermediary between both ends. So you can see it as a human being, my head is cut off from my body, and my body can function on its own, and I can plug in any head into my body, right? So this literally means I can use my body to power any form of head. I can power Elon Musk's head. I can power Ariana Grande's head. So whatever I want to do, all I need to do is just plug in a new head into my body. I know that sounds really creepy. But yeah, now that we realize that there is an increasing technology rising in the industry, and there is also increasing competition. I mean, more shops are coming up, and your consumers are also demanding for more daily. That means you need to level up and scale up your business to stand out among these competitions. You need to meet the demands of your users. And there is a need for new technology that would help us solve this problem. And this is where headless commerce come into play. Headless commerce is designed to curb many limitations of traditional commerce. With headless commerce, developers can now independently build the presentation layer, the business logic, the database layer, integrations, and utilize some other headless commerce API solutions with no interruption to the customer experience. This is really cool because this is one of the issues we face with traditional commerce. There is a need for us to scale the platform. There is a need for us to adapt to emerging changes. But then there's friction between several layers that move around in commerce. And with the traditional commerce, it becomes hard and harder day by day for you to make all these changes without interrupting your customer experience. So to put simply, headless commerce is a practice of separating the front end from the back end of an e-commerce store. And this approach allows you to decouple components into independent modules. So you have your front end, which is like the head, separated from the back end. And this allows for more flexibility, better performance, and efficient development. So this is what a headless architecture looks like. First thing to note is that there is no presentation layer when it comes to the headless commerce. The presentation layer is independent. It's like a different entity on its own. And all you have is just APIs. So you can see the business logic, the transactional engine, third-party integrations, and your content management system all working independently and communicating via APIs. And you use the same APIs to connect with your presentation layer on any channel. This can be on any it can be on a website, on mobile apps, or any other device. This is how much flexibility Headless Commerce provides your business. So now that we understand what Headless Commerce is, I would like to show you how Headless Commerce solves the challenges experienced in traditional commerce. So generally, Headless Commerce brings better performance, it allows for easier scaling, higher security, and much more. But let's take a look at some of the challenges we mentioned earlier in traditional commerce and see what Headless Commerce does for you. So speed and flexibility. Now we know that with the headless commerce, each component is built independently and they can be deployed independently, which means the issues we're experiencing with high processing time would be reduced. There would no longer be like delays in load time of some web services. And now your UI engineers can, build with their favorite technologies. Your backend engineers can build with their favorite technologies, and your content engineers can work with best of breed CMS, which means every team can work independently and it allows for more flexibility and effective collaboration. Cost and scalability. Now, with the headless commerce approach, you can utilize static site generators to build the pages of your presentation layers, cache them, and serve them over CDN. And this leads to better performance and a less expensive architecture. And as a result of this, it becomes easier for you to scale your platform. With the use of several third-party headless solutions, you can easily scale your platform by default without having to even do so much work. And if you choose to do it manually, it becomes easier for you to scale based on the requirements of components in your application, because now you have the flexibility of working independently on each of those components, which is really cool. Now, when it comes to security, whatever issue that arises in your platform or your architecture, it's easier for you to find and debug them because the complexity of your application is now reduced into like smaller components, and you can easily debug and find issues. You don't have to struggle with trying to deploy the entire application. You can just find an issue that arose from one component, fix it, and just deploy that issue. Now, the APIs in the headless commerce architecture are still prone to minimal attacks. But the good thing is you can leverage on third-party headless solutions to manage the security of your application. I mean, this is really cool because you don't have to worry about, working 24/7 to ensure that your application is secured. You can just leverage on a solution whose full job is to ensure your application is secured. And in the long run, it makes your application so reliable. And lastly, modularity. Like you can imagine, now it's easier for you to encapsulate code functionalities into modules and reuse them in several other components in your application. And now your developers can test new features, build new features, and adapt to new technologies easier than you could have done before. Now that we understand what headless commerce is and how it solves most of the issues, I mean all of the issues you experience with traditional commerce, I would like to introduce you to Commerce Layer, which is a solution that supercharges the headless commerce architecture. So Commerce Layer is a headless commerce platform and order management system that lets you add global shopping capabilities to any presentation layer with ease. And what this means is Commerce Layer is a commerce API for developers. We provide you with tons of APIs that you can use to supercharge your headless commerce platform. It's purely transactional. We manage all the transactional data and functionality of your platform, and you can integrate with any CMS of your choice, like the amazing Strapi, and add international shopping capabilities to any presentation layer. You can handle all your transactional functionalities on Commerce Layer, integrate with the best tools you use, the best of breed CMS you use, and you can now make your content, or rather your products, shoppable on a global scale. So first, Commerce Layer provides you with a dashboard where you can structure your e-commerce business models. You can, create some SKUs and do some structuring to your organization. And we also provide you with an order management system, a return management system, and commerce APIs for you to integrate into your preferred stack, into your preferred CMS like Strapi and preferred technologies. So now it becomes much more easier for you to work with Headless Commerce because now you are able to segment your business logic and your transactional functionalities away from your presentational layer. Now, there are three key building blocks of Commerce Layer, which is headless, transactional, and global. First is with Commerce Layer, you can now decouple your presentation layer from your core business. I mean, you can now have one backend powering multiple storefronts. It's now easier for you to manage all the transactional data of your business on Commerce Layer and use that data to power several channels. Now, it's also important for you to note that Commerce Layer is not an e-commerce site builder where you can, drag and drop stuff and build your presentation layer, add some content behind, and then, like bootstrap an entire e-commerce application. No. And that brings us to the second key factor, which is transaction. So Commerce Layer manages the transactional data and functionalities of your e-commerce platform, which separates content from commerce. So Commerce Layer is not a content management system. We don't manage your content. You manage your content on your most preferred content management system like Strapi, and we give you the flexibility of integrating your content from a CMS into your e-commerce platform. Now, this transactional data can include your prices, stock, orders, and much more. And the last factor, or rather the last building block, is global. So Commerce Layer helps you to sell in multiple markets with independent business logic for each of those markets without any form of data duplication. So for an example, you have you sell in London, in Nigeria, in China, or several other countries. With Commerce Layer, you can now have different models for each of those markets because every single market will have their own requirements, and there's a need for you to structure those markets independently. But now with one single account on Commerce Layer, you can structure the markets for each of your businesses, and you don't have to duplicate content because now you have just one data powering all your applications, rather powering all your markets. And you can use that same data to independently derive or set up your markets. Unlike the traditional commerce where if you would want to, let's say, scale to different countries, you have to have a different set of data for that particular market. But now with one data, you can just structure several markets. So now that we understand the building blocks of Commerce Layer, let's take a look at how Commerce Layer supercharges your digital experiences. Now, what you should know is Commerce Layer is an API-first platform. And as a result of that, we support Headless Commerce natively. I mean, Commerce Layer provides you with commerce APIs for tons of stuff like inventory, order management, shopping carts, checkout, promotions, shipments, and much more. Now, the thing is, Commerce Layer gives you the flexibility you need to, scale up the headless commerce architecture and grow your business. Commerce Layer was built with a vision to solve a problem that was prominent in the traditional commerce era. And here's a quote from our CEO. The best projects are always driven by creativity. But the problem is that creatives and engineers generally have conflicting priorities. The former always push for innovation and creativity, while the latter push for security and stability. And this is a big problem because we've identified that technologies are rising daily. There's more competition in the market, and you want to stand out. You want your customers to be happy. But every experience you give your customers come from the technical logic of your commerce application rather. So for you to satisfy your customers, there's a need for you to, put in the best in the engineering logic of your business. So now that your UI engineers and content engineers want to be creative and innovative to solve the experience problem, your engineers also want to ensure that the platform is stable and scalable. So while they are both working in one complex and monolithic architecture, it becomes harder for them to collaborate and make the best out of what they do. And this is why the headless commerce exists. So Commerce Layer promotes best of breed approach that encourage engineering teams to integrate the tools of their choice. I mean, this allows every team to have an agnostic setup. Your front-end team can use the best tools they want to use. Your back-end team can use the best tool they want to use. The content team can use the best CMS they want to use so as to achieve the aim of satisfying your customers. And along the line, this leads to effective product development flow and collaboration. And this is an example of what the headless commerce architecture looks like with Commerce Layer. So we have 3 building blocks. We have Commerce Layer, we have your headless CMS like Strapi, and we have your code repository. So as a merchant, you go into Commerce Layer, you structure your organization, you add some prices, you add some SKUs, which depicts items you're selling in your organization. And you don't manage any form of content on Commerce Layer. So what you do now is your content editors go straight to Headless Commerce and you import SKUs from Commerce Layer into your Headless CMS using our webhooks, and then you're able to prepare the product catalog for that particular item. And now your UI engineers and your backend engineers are also working simultaneously, building the best experience you can deliver to your customers. And with this, you can serve the code, serve your content, and serve this transactional data to the CDN. And with APIs, you just do all the amazing stuff you want to do on the client side on your application. And also one other cool thing is, as customers make purchases on your platform, with one of our commerce APIs, you can send requests back to Commerce Layer, which now tables those orders in the order management system. And as a merchant, you can go ahead and fulfill those orders there. Same applies to the return management system, which helps you to manage returns. I mean, there's tons of cool stuff you can do with Commerce Layer and the headless commerce architecture. And this just shows you a background context to how all that works. Now, there's a lot you can build with Commerce Layer. You can build a new e-commerce website from scratch. You can make your existing website shoppable on, even if it's a mobile app. You can have let's say an ebook website where you sell ebooks, and you can just use Commerce Layer to make that particular website shoppable. You can make your existing wearable device or voice devices shoppable. You can make print catalogs shoppable. I mean, anything that involves exchanging money for goods and services over the internet can be made possible with Commerce Layer. We have tons of commerce APIs that would help you bring your ideas to life and serve these ideas on several channels like your mobile devices, laptops, desktop computers, voice devices, QR codes, chatbots, even IoT devices, and much more. So now, despite all the mouth-watering benefits, Commerce Layer is not the right solution for everyone. I know that's sad. So if you're a small business with small requirements, maybe you also have a single market presence and just a few engineering resources, and you also have a desire to start selling as soon as possible, then Commerce Layer might not be the best fit for you. Because you just have a few resources you want to sell quickly. So you don't really have the engineering resources and time to invest into building the best experience for your customers. So you probably want to rely on teams and some site builders to set up your UI quickly, and you just want to go to the market quickly. And also you would no longer be able to utilize the global capabilities Commerce Layer provides for you. But however, if you are a growing brand and you want to expand your business internationally, you want to take full control of your content and your user experience, you also want to increase conversion and revenue, then Commerce Layer is the best fit for you because we have all you need to grow your business. So it is dangerous to have unsatisfied customers in this modern and competitive and fast evolving age. Hence, there is need for new and modern technologies and architectures like Headless Commerce and Commerce Layer to eliminate factors causing dissatisfaction and improve the business and technical logic in commerce. And this brings us to the end of this talk. So I want you to review what you have currently and take a look at the architecture your business has and decide if you are actually satisfying your customers and if you are meeting up with emerging technologies. And if you'd like to know more about Headless Commerce, please check out our comprehensive Headless Commerce guide, which will take you through most of what we discussed today in detail and how Commerce Layer can help you achieve your e-commerce needs. You can also check out our core concepts, which covers most of the core concepts of headless commerce that we care about at Commerce Layer. We also have a data model document that covers the relationships between several resources in our commerce APIs. So you might check this out first, just to get an idea of what Commerce Layer look like before you get started. We also have some open source projects on GitHub that you can utilize to, develop your project and bootstrap everything faster. So thank you so much for listening. Feel free to leave your questions. I would be replying to them on Discord, and I would also share links to the resources mentioned in this talk in Discord. Thank you to Google and GitHub for some images used in my slide. And yeah, thank you so much.
I don't know about everyone, but it's starting to look like e-commerce is really, really hot. Thank you so much, Balaji, for that amazing talk. Super stoked to have you at the conference. Side note, I know Balaji outside StrapiConf, so it's really great to see him come here and interact with the Strapi community. And he was kind enough to take us on a break. So we have another break coming up next. You can take a walk, you can go chat with the sponsors, you can play a game of Among Us, and then come back and meet us here. We have workshops, very, very interesting, in-depth workshops from some really, really cool companies. Plus, it's not too late to register. Check out the workshops tab on the StrapiConf website. Look for a workshop that you're interested in and yeah, get going. Also, that's it from me. It's been an honor serving you all digitally today. And I just want to thank you again and see you in the Discord.